record on the computer. All right. So I'll move this here. Okay. So yeah, let's go straight to question one. Question one, once again, I wanted to start with bonds. I felt like, we got to do it, and let's just do it now, get it out of the way. Yesterday's session was quite literally the hardest version of any bond valuation question I believe you will have. Now it's more so about understanding the topics at play, understanding what constitutes a bond, what formula to use with a bond, which is literally only one, and just doing it again and again and making sure that you don't make those little weird mishaps or weird little mistakes. So once again, we're dealing with Fuji TV, which issues a bond at an 8% coupon rate, okay, at a $1,000 face value, all right? And we know that the interest is paid semi-annually, all right? So already there, I'm gonna ask y'all, what should be our coupon rate? I mean, our coupon payment in this case. If we know that the coupon rate is 8% and interest is paid semi-annually and the face value is 1,000. Remember that a coupon payment exactly is equal to the face value times the coupon rate divided by frequency. So in this case, all of you are absolute gangsters. You know that this is going to be $40, okay? We also know that the bond has a 25 years to maturity, okay? So it has 25 years. So in that case, with all the information provided, what's our N? If we know that it has a 25 years maturity, we know that N is equal to years, number of years, times the frequency. Exactly. So we have 50 as being our N. Now, obviously, if we have an exam question, it's never going to be easy. There's always going to be some sort of nuance. And in this case, the nuance is as follows. The bond does not pay the first 8 coupon payments, okay? And instead, it will make half of these payments at maturity, okay? So let me ask you this. How many payments are we missing? How many total payments are we missing? How many total payments are we missing right here? Yeah, we're missing 8 total payments, all right? Very simple question. How many payments are we going to get back at maturity? How many are we going to get back at maturity? Exactly. So at maturity, we're going to get 4 payments, okay? So you could say essentially, what is it? It's $40 times 4. We're going to get $160 at maturity. We're only going to get a portion of them. That's pretty interesting. Okay, pretty important. And then we're also telling you that investors require a 7.8 return, a 7.8 return. So in this case, what would be our KV if we know that KV is equal to the yield to market divided by frequency? Exactly, Marianne, it is 3.9%. All right, so we have a lot of really cool information. We have pretty much everything that we need. And now at this point, if you are on the exam or if you were preparing for this course, you would know that it's pretty darn sure that we're dealing with the chapter bond valuation. And when you're dealing with the chapter on bond valuation, there's quite literally only one formula that you need to use. I'm kind of screenshotting it for you right now, just so you have it on screen. And the formula looks like this, okay? I'm sorry that it's pixelated, but that's the formula. And there's only one formula that we need to use here. Before we do that though, the second step, I believe, and it's always a really good step, especially when practicing, is to create a timeline because we want to know what the heck is going on. We know that this bond, 25 years from now, so at t equals 50, we know that the bond will essentially mature. However, we also want to understand that we are going to miss a few payments. We're going to miss a few payments all the way to the 8th one. All right, so that's pretty important. And we could skip a few years all the way like this. Now, once again, when you're making a timeline, it doesn't have to look exactly like what I have on screen right now, but you want to be able to visualize the nuances at play here, because that's really going to play something when we need to plug in our stuff into our formula. Now, You'll see what I mean in just a second. We could break this down into a few steps. Okay, so let me ask you this. When is our first payment occurring? When is our first payment occurring? If we know that the first 8 payments are not happening, when will be the first payment? If we know that the first 8 payments are not happening, at what T? The first payment, the first coupon payment. It'll be at T equals 9, 100%, right? Because we know that these are essentially representing every 6 months, right? So every 6 months, twice per year. In this case, we would be at T9. The first payment will occur at T9, the actual effective payment. So we know that we're going to receive $40 as a coupon all the way here up until right here. So we know that we're going to be getting all of these coupon payments, okay? All of these coupon payments. And if you know me by now, you know that I'm a big fan of breaking down our problem into pieces, right? And you're probably already done the question by now because you're a pro. But this would be part A. This would be part A of our question, and we're going to just write this as being our coupon payments, okay? Because we have some adjustments to make. Now, another thing that we need to note is that because it's a bond, we're for sure going to get some payments done at maturity. Typically, it's only the face value. But in this case, we know that we're receiving a little bit of extra money because we missed a few coupons, right? So we know we're going to receive this much extra, such that at T equals 50, how much money are we actually getting at maturity? How much money are we actually getting at maturity? Can somebody tell me? It's $1,000 and what? What are we getting at T equals 50? What is our F at T equals 50? Right? We know we have our face value and we know we have our missing payments. So what is our total F? There you go, 100%, exactly. So this would be our total F. Now, once again, the reason why, and I said this yesterday, and if you weren't there yesterday, please go look at the recording. But the reason why we're breaking this down into 2 pieces is really important because we need to look at how many discounting periods we're going to have. And when we plug that into the formula, like yesterday, we're going to break it down into pieces. But it's really important to understand why we're breaking down part A, which is the coupon payments, away from part B, which is the face value. Now, for all intents and purposes, when we're doing a question like this for your exam, which is complicated, with nuances, with adjustments to be made, it's very important for you to remember that the face value, what it really means in the context of intro to finance, we're really talking about how much money are you getting at the end, okay? At maturity. That's really what we're asking you. How much money are you getting at maturity? That's what we want to know. And at maturity, this means at T equals 50, which we essentially drew on our timeline right here, we know that we're going to be receiving $1,000 plus the missing payments, right? We missed 8 payments, but 4 of them are coming back. Sorry, kind of bugged. So we're getting $40 times 4, so $160 extra. Okay, so that's why we have 1,160 at maturity for part B. Okay, so very important to know. All right, and once again, I always say this: the present value of a bond, the price of a bond, is equal to the sum of all of its future discounted cash flows. So in other words, it's equal to the present value of part A plus the present value of part B, which is exactly what you see right here in our formula. Okay. So let's begin with part A, and we'll get the answer super quick. So let's do part A. And we're just going to identify all of the different things we need in a valuation, in a bond valuation formula, which is our C, which is our KB, our F, and our N. So could somebody tell me what is our C for part A? It's easy. It's right up on the screen. Amazing. What is our KB? What is our KB? What is our KB? Nice. Thank you, everybody. Thank you so much. Now, if we just look at the green portion of our timeline, just at the green portion, do we have an F? Just in the green portion, do we have an F? No, we don't. Okay. If we're just looking at this green portion, At what's highlighted in green right here, we do not have an F. Because our F, we're going to put it in part B. Okay? We're going to use the formula again for part B. So for all intents and purposes, part A has no F. Okay? So F is equal to 0. And if F is equal to 0, we would have 0 here, and then the denominator wouldn't matter because 0 divided by infinity is still 0. Okay? And for that reason, this doesn't matter anymore. So we only care about this portion of the formula, essentially the portion dedicated to coupon payments. Okay? What is our N? If we miss the first 8 payments, what is our N? Okay? We missed the first 8 payments, what is our N? Marianne says 41. If we miss the first 8 payments, what is our N? It's important. Elizabeth says 42. What do y'all think? What is our N? I need a few other people to put it in the chat. What is our N? We can literally count it on our fingers, but I don't know if we want to go count for 40 payments. But Elizabeth says 42. Willie says 42. Marianne says 41. I'll get one more person to do it, just for fun. It's 42. Yeah. A really good trick is like what I said yesterday. The payments that you missed, that's the payments that you're going to take off from the total number of N's that you were supposed to have. We were supposed to have 50 payments. We missed 8. So 50 minus 8 is equal to 42, such that our N is equal to 42. Okay. With that said, I would like you all to plug in all of that good stuff and tell me, what does it give you for your present value? I'm going to wait for like one more person to give it in the chat, and we'll go from there. But so far, thank you so much, Elizabeth. That's amazing. One more person in the chat. We're doing really good time, honestly. Thank you. Okay, so I'm going to go and believe that this is 819.98. Okay, so that's our present value. Now let me ask you all a question. You know how I am. I'm annoying. Where is this on our timeline? Is it at T7, T8, or T9? Where is it on our timeline? Elizabeth says 9. I need 2 more people to give it a shot. Where is this on our timeline? Yusra says 8, Lee says 8. And Elizabeth, we had a session, and I think a better way for me to explain it, I don't feel like I explained it as well then. The best way to look at it is to say the number of payments that we missed will be the position of our present value, especially with bond valuation questions, okay? Typically, you would just say you come one period before, but in this case, the best way for you to remember it and for us to kind of all agree is that the number of payments you missed will be the position of your present value when we're doing these bond type of questions. In this case, we missed 8 payments. And for that reason, we're going to be at T equals 8. Is that fair? Is that a pretty good rule? Could you like follow that one right on your cheat sheet? Are we good with that? Amazing. Okay. It's just a good way to look at it. So our present value will be at T equals 8. Now, is T equals 8, is PV 8 today? No, it's not. So because of that, we need to discount this to the present value. So this was actually 8 right here, and we need to find the present value at 0. So what we would do is we would take PV 8 over 1 plus KB to the power of 8. And I'm going to ask you all to tell me, what is the present value of part A? What is the present value of part A? I need one more person to give it a shot, but so far so good. Thank you so much, everybody. All right, so that's our present value at T equals 0. However, that's only for part A. Now we need to do part B. So we're just going to scroll down a little bit, and it's really rinse and repeat at this point, okay? And I'm going to assert a point that's very, very important, though. So for part B, what's very important to understand is that part B, essentially, it only occurs at T equals 50, right? It occurs right here. It's one singular payment that happens at t equals 50, essentially 50 payments from now, 50 semi-annual payments from now. But because we're only looking at F, because we're only looking at this thing that we're supposed to receive at maturity, the specific lump sum at t equals 50, there are no coupon payments, okay? So what I want you to understand is that this right here, right? This right here would be 0, okay? And for that reason, all of this in your formula, you won't even have to use. You will only have to use this portion of your formula, okay? And this becomes much more obvious when you just define all of the things we need, right? We need our C, we need our KB, we need our F, and we need our N. Now, of course, do we have a C for part B? No, it's 0, exactly. So that's super clear. And our KB, it's the same, it's 3.9%. And our F in this case, once again, it's 1,000 plus 160. So it's 1,160. And what is our N? What is our N? N is 50, you know, because there's no missed payments. There's nothing that we didn't go through. It's simple. We just got to simply discount it back to t equals 0, such that our N is equal to 50. Okay? And in that case, our formula looks super simple. All that you got to do is do the following. You would take your F over 1 plus KB to the power of 50. Now, what would that give us? Okay, solid. Amazing. So now that we have all this information, I guess we could go in orange. We could write it at the top. No, we'll write it at the bottom. Sorry about that. So as we know, the price of a bond is simply equal to the present value of its future discounted cash flows. In this case, its future discounted cash flows, we group them into two parts, part 1 and part B. So you would just do P1 plus P2 such that P0 is equal to how much? Is that fair? Yeah, that's fair. That's very fair. One more person just for fun. Want to make you work a little bit. Amazing. Cool. Very good. So I always like to kind of do a summary of what we covered at the end of a question. Listen, this one at this point should be easy for you, right? It should be simple. The only nuance was, where do we put a present value of part A, right? Once we plug it into the formula. But now we know a rule that's amazing, a rule that tells you the amount of payments that we missed will be the period at which our present value will lie once we plug it into our bond valuation formula. And then you simply have to discount it back to P0. That's probably the only hard part of this question. There was nothing else. The face value portion is simple. Simple discounting back to P0, right? So having that in mind is super duper crucial. I think that if you see a question like this on the exam, you know what to do. Overall, how do we feel? Are we comfortable? Are we happy? Like, what's going on? Is this okay? Okay, perfect. Good stuff. So let's go straight into question 2. Go straight into that one. This one's fun. This one's it's a fun one. This one's going to be very fun, actually. This one is a classic missing cash flows. All right, this one's it's going to be a long one, but it's going to be a fun one. It's also in our interactive mock exam, but it's always good to kind of do it together. I don't think that you'll have a question as hard as this on the exam, but if you're able to run through this one, in my opinion, you're able to do pretty much all questions if you're able to go through this, because this is really as hard as it gets, in my opinion, in terms of just missing cash flows and all that jazz. So let's go through it, okay? Let's do that. So your friends, okay, this is a missing cash flows. This is chapter 5, time value of money. You can use your flow chart. It always helps. But your friends Lee and Quan, okay, this is a pun or like a historical fact from Singapore, Lee Kuan Yew, if you're into that stuff, are struggling to solve for the missing cash flows of the following cash flow stream. In fact, they're convinced that X must be 115.16. Okay. And you have some sort of cash flow stream on screen. We're not too sure what it looks like. We kind of need to read more. Now they're telling you, hey, the present value of the above cash stream with annual payments is the following amount: 5,095. It's as easy as that. So we know that we have our present value. Let's go and highlight that, I guess, yeah, in green. Okay, so we have our present value right here. That's already some pretty good news. We're getting information. So present value. And we know that the discount rate, all right, is 8.9411%. However, it's compounded 365 times per year. Now, let me ask you a question. This rate right here, is it an effective rate or is it a quoted rate? Could somebody tell me in the chat? Is this an effective rate or a quoted rate? I need a few people to write it in the chat. Effective or quoted? One more person? Thank you so much. Yeah, that's a quoted rate. And I just want to double down on a rule, okay? The quoted rate, you will know it's a quoted rate once you have a percentage, all right, followed by compounded daily, compounded monthly. If you see this pattern, you know you have a quoted rate, okay? An effective rate, all right, an effective annual rate will simply be the rate, nothing else, all right? Use that, to your advantage. You'll know when to do something and when not to do something. So if we know that this discount rate of 8.9411 is compounded 365 times per year, what does that 365 represent? Is that NMF? What is it? 365 times per year in our like effective rates formulas. Somebody tell me. One more person, just for fun. It's M. Yeah, okay. Perfect. Good stuff. Good stuff. Yeah, so that's going to be our M. Very well done. Okay. So it's our M. Okay. And then they tell you that this cash flow stream, it pays a growing annuity. Okay. A growing annuity starting at the end of year 3, for which it has a growth rate of 4%. Okay. So they're telling you that there's a growing annuity starting right here. Okay, we could even put in a different color. We'll put in the same color. They're telling you, hey man, there's a growing annuity that will begin right here. Okay, very important. And they're also telling you that it has a growth rate of 4%. Okay, and obviously, if we're dealing with a growing annuity, the growth rate is obviously important. It's a very pivotal part of the formula. And then they're also telling you, last part, it pays a perpetuity starting the year 7, starting the end of year 7. So we can highlight that in a different color as well, just to really make sure that everything is grouped up in its pieces at the end of year 7. So now I'm going to be funny and I'm going to ask you this. When is our growing annuity done on our timeline? When should it be over? Based on what we just read. If we know a perpetuity begins at t equals 7, exactly. I mean, for sure, right? This is a trick that they may do. They may be as annoying as this. It's rare, but in the case that they try to get you to deduce something, well, if the perpetuity begins at year 7, obviously our growing annuity would be essentially the portions between. Okay? So what they're telling you here, they're telling you that this growing annuity is going to increase as so up until t equals 6. Okay, so you could say we have G here, we have G here, we have G here. This is essentially going to be one part of our question. And we're also telling you that starting at the end of year 7, you're going to have a perpetuity. Okay, a perpetuity up until, well, forever. It's a perpetuity. Okay, so you're going to have a perpetuity up until essentially forever, starting t equals 7. All right, such that technically This would also be 2.5x. This would also be 2.5x. This would also be 2.5x. Okay. And then another thing that I'd like to note is the first portion of the question. The first portion of the question, we can highlight it right here. Would it be fair to say that these two payments are the same? Would that be fair? Is that like an obvious fact to all of us here that 505 is the same as 505? Okay, cool, amazing. So we now have something that kind of, we're getting somewhere, right? We have this timeline that we could break down into three pieces. We have the first part, which is two payments that are identical. So technically we could call it, if we use a flowchart, payments that are happening for a definite amount of time that are happening at the end of the year that are the same. What do we call that if you use your flowchart? If I'm not mistaken, we're going like this, like this, like this, like this. Where are we on our flowchart? If we know that we have payments that are happening for a specific amount of time, all right, they're happening at the end of the year, and those payments will be the same. So T1 to T2, what type of formula? Yes, we have a normal annuity. Thank you so much, Elizabeth. Yes. So that's going to be part A. We know that this is a normal annuity. We're pretty cool with that. So we could like write this here. We're going to have here normal annuity. Okay. And then obviously in the question, what is here? What is part B? What is part B according to the question? It's a what? It's a growing annuity. Exactly. Amazing. Thank you so much, Shane. Hell yeah. And then what about the last part C, essentially? It's a perpetuity. Exactly. All right. So it's a perpetuity. So, and then we're asking you, the last part of the question, we're asking you something. We're telling you, hey, by the way, what is the value of the missing cash flows? What is the value of our little friends here? This little X, okay? This is what we're asking you, the value of the missing cash flows. So far, are we okay with what I just did? We just put the information from the text onto a timeline to understand what the heck we're doing. Are we okay with that? So far, we good? Okay, good, happy, amazing. So now the next step, we're gonna try to define our mission. What are we gonna do here? Like, what's the first, big picture mission? And then we're gonna go into our, individual steps to get there, okay? Well, what we're trying to do here, once again, is we're trying to solve for X, okay? But the thing is, it's kind of a strange one. How do we solve for X? When you're given a question like this, and I'll write it at the top, it'll be like our mission statement, okay? When we have a question like this, we need to remember the very core of what TVM is all about, and honestly, what finance is all about. We know that essentially the present value of something is equal to the sum of all of its discounted future cash flows. All right, you could just write it as DCF if you want, actually. Discounted future cash flows. I don't know why I'm being a little bit dyslexic right now. But there you go. It's future discounted cash flows. And in this case, we know that we broke down all of its future discounted cash flows for this question as being PV is equal to part A plus part B plus part C. Okay? Technically, can we all agree that we already have our present value? Is that already a number that we have? I feel like that's a yeah, we already have our present value. And technically, say no in the chat, okay? Say no in the chat if it's super easy to get the present value of A, part A. Would it be super easy? Say no in the chat. Yeah, hell yes. It's a simple and normal annuity, very simple. So we have A. And then part B, it's still the same old formula that we're used to, right? There's nothing new to it. So we could do that as well. And then part C, well, part C is the actual, that's the guy that's a little annoying, right? That's the person that always talks in class, because here we need to solve for X, right? But the thing is, that's exactly what we want to do. So if we know the present value, we know A, and we know B, it becomes very, very, very easy for us to solve for C. Exactly. So that's going to be our mission. our mission now is to figure out the answer for A, figure out the answer for B, simplify C, and then just put all of that together and try to solve for C. C obviously being X. It's as easy as that. Okay, so that's going to be our mission for the next like 10 to 15 minutes together. Okay, now one thing that I'd like to say though is when you have questions like this, all right, we need to remember that we were able to break it down into this timeline. We broke it down into this individual pieces. But the thing is, before we start solving for stuff, we got to get rid of our rates. We got to, we got to clean our rate stuff a little bit, because right now we only have a quoted rate. So we can't plug that in into any of our formulas, because all of our formulas are dealing with, as you can see, and I'll highlight it again, with annual payments. Okay? So before we start plugging stuff in, it's very important for you on an exam to remember what type of payments we're dealing with. In this case, we're dealing with annual payments and we have a quoted rate. So we need to bring that quoted rate to a essentially effective annual rate. So that's going to be our very first step, okay? Our very first step together. So I believe that y'all are pros by now, okay? I believe that y'all are all pros. So I'm going to ask you, what is, we call it part one, what is our quoted rate turned into an effective annual rate? I need a few people to tell me what that is, just so I make sure that we're all doing really well. You guys are awesome. Absolutely awesome. Thank you so much. Okay, I'm gonna trust y'all with that one. You know what's funny? This whole mock exam, literally, I made it like, out of thin air. So I'm doing the questions with y'all. So I'm trusting y'all as we go. But that's going to be essentially our effective annual rate. Okay. So now we have our effective annual rate. I'll let one more person solve for it, just to be sure. One more person. By the way, so far, is there anybody in the chat that does not know how to get the effective annual rate? Just to be sure. It's very simple. All that you're going to have to do is follow this rule. Okay, just to be sure. I don't want to leave anybody hanging, but it's like this, the power of m minus 1. Okay, perfect. Thank you so much. So now we have a very important piece. We have our effective annual rate. We're super, super, super stoked. Okay, so we can move into part 2, which is solving essentially part A. So now we can move into part 2. So solve A. Now we know that this is a normal annuity, okay? Now with a normal annuity like this, with something on your formula, on your timeline that looks like what we have for A, there's actually 3 ways of doing this. Either you could simply plug all this nonsense into your calculator, do it in 2 seconds, or you could use a normal annuity formula, or you could discount them one by one to find, their individual present values and sum them up together. I'm gonna be a old man and I'm gonna kind of use the formula just because I feel like it's the best practice and it's always good to get in your reps. So we'll go with that. And you guys could obviously tell me what is the present value. Although I already kind of know what it is. So present value is equal to payment. Okay. 1 minus 1. 2. So could somebody tell me what's our present value? Now, obviously, we know that our payment is going to be 505. We know that our K is going to be what we have here. We know our N is obviously going to be 2. And our K, once again, we have it already. Okay. So with that said, could somebody tell me, what did you get for your present value for part A? Somebody tell me, what did you get? And on the slide, I'll write it just to be super transparent. I need a few more people. Okay, awesome. Awesome stuff, awesome stuff. So you guys are doing amazing. So our present value, yes, it'll be equal to 884.13. Write this like that. Okay. Super solid stuff. Very proud, very proud. I'm very proud right now. This. Cool. So now we're going to move on into the growing annuity. Okay. We can move on into the growing annuity. We can write it here as being part 3. Let's solve for B. All right. Now the first part to remember here is that we're dealing with a growing annuity. Okay. So you need to think, well, what are we going to plug in onto this formula, right? What are we going to do? Well, this is interesting. Okay. Now, actually, I'm going to write the formula down and I'm going to talk with y'all and I want you to tell me, what do you think? Okay. It's just because I want you to have some context. So I don't want you to get lost on your exam. So you'll see what I mean in just a second. So I'm going to write the formula. We're going to use this as an opportunity for a growing annuity to kind of talk about what this is all about. And if you're very fast, you could go ahead and kind of start. It's very okay. No worries. I'm just going to kind of use this as an opportunity to talk about a few things that I believe are important. So I don't want you to make a little mistake on the exam. That should be good. Okay. So let's just say what we need. We need here, we need our K, we need our G, we need our payment 1, and we need our N. Okay. We're going to define all of these together, and I'm going to see whether we need to have this conversation or not. So we're going to have our payment 1, we're going to have our K, we're going to have our G, and I guess we'll put our N right here. Okay, we'll begin with the easy stuff. What is our N? What is our N? Elizabeth, awesome. 4. What is our G? It's the same thing. G is 4 as well. What is our K? Write that in the chat instead because what is our K? Exactly. Thank you. It's obviously going to be the same one. Now, let me ask you this. What is our payment? I need everybody to write it in the chat. What is our payment? I only got 2 stuff in the chat. One more person, Yusra, what is our payment? Yusra Walid. What is our payment? I just want to see what's up. It's important, especially Walid. It's very important. I want to know that you guys know this and that you guys visualize this. That's exactly not the answer. Exactly. It's not 887.12. It's actually 853. It's 853, and let me tell you why. I'll put this in in red. It's very important because this is a mistake that sometimes it happens. So this is 853. Now the reason why this is 853, I'll put it onto our timeline. Okay. Essentially, what this formula is telling us is telling you, hey, we have this payment, right? That's occurring at essentially T3. Payment 1, and we know it's going to grow every single year. Okay. And this is very similar to our perpetuity formula and so on and so forth. It's telling us that your payment 1 will give you something 1 period before. So in this case, they're telling you, hey, you're going to get essentially your present value at 1 period before. You're going to get your present value at PV2. Okay. And the reason why we don't want to multiply by G right now is because if you multiply by G, you're going to be getting essentially your payment at T4. And when you plug that in within your formula, you're literally going to get the answer at T3. Okay, so then you would have to discount by 3 periods to get to PV0. Now, I feel like this is pretty obvious, but the reason why I say this, you probably all saw an example in your practice problems, probably even in my notes, where they had essentially a payment that occurred at T0. Okay, so what they did is they did 1 plus G to get the payment at T1. Okay, have you guys seen that in class once, or like in your practice problems or something like that? Just say yes or no if at least we're still having the same conversation. Yeah, we've all seen that where they did payment times 1 plus G, especially when it happens at T0. And the reason why they did this, and I'm going to highlight this in purple. The reason why they did that is because they want to simplify this for you. They want to simplify it because they know because this is at payment 1, if you discount it, you're naturally going to get a period before, and you're naturally going to get the answer at PV0. Okay, so that's why they're making that adjustment in class, because they know that because you're doing 1 times 1 plus G, you're therefore going to get payment 1, and therefore because we know thanks to the growing annuity formula, we always come 1 period back, 1 period before. That's why it gives you PV0. So that's why they do this thing when you get a payment at T equals 0. The reason, once again, why they did that is because if they used, and I'll put this now in this grayish color, if they use this, if they use payment at 0, they would have gotten the present value at what period? They would have gotten the present value at what period if they took payment 0? Exactly, Elizabeth. They would have gotten PV at -1. Now, for a teacher, that's a way more complicated topic to explain to a student. Okay, so that's why they always do what we highlighted in purple. All right, so that's why they do that little mechanism in class, and that's why right now we didn't have to do it because we knew that we were at T3. We knew that. We knew that we were at T3, so our present value is going to be at PV2. So it's not a problem for us. We don't need, like, that's still something that we can contextualize and see and understand. So that's why using a timeline is so important. And they don't teach you this always in class. It's really important to visualize that because on the exam, they're going to be weird. Like I'm weird right now with my exams, with my like mock exams. They're hard, right? So sometimes you need to visualize that and kind of be ahead of the ball. And just one student not making that mistake like we had right now is so important. Okay, so taking a step back, this little like rant that I went on, like, do we all understand? Do we get why it's important to kind of visualize it? Are we good? Yeah. Okay. Cool. Dope. So with that said, I would like to just ask you, what is the present value of this perpetuity at PV2? What is PV2? Dun, 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 dun. Okay, cool. That's a good answer. I just, in my notes, I put a wholly different one. But yeah, that is the correct answer. So you guys got 2, 8, 9, 8, 5, 3. Okay. Now we're gonna go with the classic spiel. Is that the present value today? The answer is no. It's at PV2. So we need to get this bad boy all the way back to PV0. Okay, so we need to discount this amount by 2 periods. Okay, to get PV0, we need to discount this amount by 2 periods. Can somebody tell me what's PV0 then? We need to discount this for 2 periods. Dun, dun, dun. I need one more person to give it a shot. Oh, one more person, because Elizabeth and Marianne, you guys answered at the same time, so I'm like, that's one person already. Let's ask one more person, like Shane or Walid or Yuska or V or who else? Give it a shot. I want them to get into reps as well. One more person to give it a shot. What do you get? What did you get? Amazing. I believe y'all. Cool. Okay. Amazing. I'm just going to highlight this so we don't forget that it was there. So that's our present value. Now, We got to get into part C, okay? But part C is interesting, okay? Part C is it's a curious one because the thing is we still got to kind of simplify it for us, okay? Let me tell you what I mean by that. So part C is solve for part 4. I mean, sorry, solve for C. All right. So the first thing that I'd like to highlight here is that C is for sure a perpetuity. We know that, okay? Now perpetuity could only have one formula, a good old formula that we all understand and love. Simple, present value is equal to payment over K, okay? So we know this, we understand that, all right? So now it's just more so kind of solving for the stuff that we have. In this case, we know what is our payment. Can somebody tell me what is our payment? Yeah, so we know that our payment is equal to 2.5x. So we have that. And what is our K? Yeah, exactly. Our K is 9.3518. Well, percent. All right, so we know that. We know that so far. We're pretty okay with that. We can visualize this. Okay, so we know that that's equal to our present value, right? Because we know that this occurs at essentially T7, right? The first payment happens at T7. So we know that this occurs at T7. Okay, so we know that we're going to get our present value one period before. Look at that, they're meeting together. That's cute. We know we're going to get our present value at PV6. Okay, so far, are we good? Do we understand that this amount that we got right here, although a variable, will be equal to PV6? Just a quick yes or no in the chat. Are we good with that so far? Just want to see. Okay, cool. So that's our PV6. Now, we obviously know that PV6 is not the present value today. So we need to discount it up for 6 periods to bring it to PV0. So technically, if we were to do this, it's the same step as per usual. If we were to do this, we would say that PV0 is equal to PV6 over 1 plus K to the power of 6. In other words, we would have something really strange going on. We would have this right here. We could write it as being 0, 9, 3, 5, 8, 2.5x over 1.093518 to the power of 6. Okay, this is what our abomination would look like. But before we kind of look at this and say what the heck is even going on, I'd like to ask you a question. Do you understand how I got to what we have here? Just a yes or no in the chat. Yeah, it's very ugly. But do we understand how I got here? Okay, so we get that. Yeah, sure, no problem. So it's totally fine. Like I know it's strange and there's better ways of doing it. I just want to show you the harder way first, so you really see like the basis of how it's exactly what we usually do. So we know that C is a perpetuity, and we know our payment, and we know our K. So Shane, I'm going to ask you in the chat, just put yes every time, and I'll like ask you questions. So is that okay so far? Yeah, and we know that essentially this would mean that our payment and our K would give us essentially PV6, right? This would be our PV6. Are we good so far, Shane? Yeah, okay, cool. And we know that PV6 is not today, so we need to discount it all the way to PV0. Is that okay? Because it's at, yeah, perfect. And we know that our K is essentially the number that we have right here. And we know that, oh yeah, no worries, perfect, cool. So it gives us this really ugly number. Now, there's two ways about like simplifying this. It's very easy. There's 2 rules to follow, and I'll give you both of these rules, okay? And you could follow either or. They both work really well, and they're going to give you the same answer, okay? So put one rule here, and we'll put another rule here, okay? So the first thing that you could do is that there's this really cool rule that says that, I'm gonna give you an example. I'll give you a really good example. Actually, I'll go even bigger than that. Let me give you all an example and you could tell me if it makes sense. Okay, so we have this right here. Could somebody tell me what's the answer to 20 divided by 2 divided by 5? What's the answer? Everybody in the chat, tell me what this is. It's equal to, exactly, it's equal to 2. Now, obviously, I could have written this as being 20 divided by 2 divided by 5. It would have given you the same thing, okay? This would have given you 2 as well, right? Because you would have had 10 divided by 5, that would have given you 2, all right? So we can all understand, and I'll ask just to be sure, that these two are synonymous. Is that true? Yes or no? Is that clear to everybody here? Yeah, 100%. Okay. So because these two are synonymous, this is just like math rules, but what you could do, it's really, really cool. Technically, you could just do this. Because this would give you 20 over 10, that would still give you 2, okay? So there's this really cool rule in math that says that something divided by something, then divided by something else is quite literally equal to 20 divided by 5 times 2, right? Instead of just dividing them twice, you could just multiply the two things that you're dividing by and just do it once, okay? I don't know, did that make sense to y'all, like that example? And okay, I hope it did. So because we know this, actually I'll leave it on the screen, because we understand that, we could write what we have right here as being simply 2.5x divided by 0.093518 multiplied by 1.093518 to the power of 6. Okay, and I'll just erase some stuff to make it look a little bit better. There you go. It's ugly, but listen, I'm trying to explain stuff. So do we understand this format of how we just simplified this ugly looking formula into something a little bit cleaner? Yeah, cool. So another way that you could have done this is that you could have simply taken 2.5 and divided by what you had here. And whatever the answer is, you would have done answer x over the same denominator, over 1.09 to the power of 6. But part 1 is probably the most, like, you know, the best way to go about it. Okay, so we have this as our monster. All right, now I'm gonna go back to blue to make it look like something that you could follow again. Anyway, so we would have PV0 is equal to 2.5x. Okay, now I'm going to ask you guys to multiply these two together. Can somebody tell me what does that give you if you multiply these two together? I'm going to start solving for, thank you so much. So just to make this simpler, I'm just going to write it as a percentage. So we have this. Okay, but we could simplify this even more. We could simplify this. And before I make that next step, so far, everybody in the chat, are we good? Shane, Waleed, Yuska, everybody, are we okay? Yeah, makes sense? No ambiguity? Okay, solid. So next step, what you could do is you could simply rewrite your formula as being equal to 2.5 divided by 15.9908%, and that's like its own thing, times x. Okay, this is another rule in math. So you could simply keep those two together, keep these two whole numbers, these coefficients together, and then divide 2.5 by 15.99%. And that's going to give you a whole other number, and that's going to be what you're going to have in front of your x, and that's going to be the simplified form of the present value of your perpetuity. Okay, so that said, could somebody tell me what is this equal to? What is that equal to in the chat? Thank you so much. So we would have 15.6347 as our x. Okay. So that's the present value, technically, of our perpetuity. It comes down to this. Okay. Now, before we make the next step, which is the easiest step, we're essentially done. Are we okay with what we just did here? Like from the very beginning of C all the way to the end? Yeah, fine. Good. If you have a question, you can let me know here at the end of the question as well, and obviously on chat. So more than happy to help. So now, the last step, the easy step, it's really you're happy now, you're done. It's we'll go with black. We'll go with essentially, I think it's what, part 5? That's where we're at. Yeah, we're at part 5. Now it's solved for x. Solve for x. Okay. So it becomes very easy. Once again, it's like what we said at the very beginning. We're back at the beginning of our mission. We know that the present value is equal to a plus b plus c. So in this case, we know that the present value that we had, which was essentially, and I'll write this here, a plus b plus c, such that we know that 5,000 is equal to 884.13 plus our other present value, 2423.96, plus 15,630 or 7x. Okay, we know that this is true. We know that the present value, all right, is equal to part A plus part B plus part C. Technically we would be done, right? We wouldn't have to do this on any other question. But in this one, obviously we do, because we need to solve for x. So what you can do is very simple, is you just, I'll put it in red, you'd subtract this amount to 5,095, and you subtract this amount to 5,095, and then you would divide what is left by this amount. Okay, simple, basic algebra. I'm gonna ask y'all, because I don't want to go through the steps. I'm gonna ask y'all, what is x? What is our answer in this case? Yeah, to be fair. Yeah, it should be around 100 to 115, just off some quick maths in my head. That would make sense. Okay, so we got 114.29. And that is our answer. Okay. Wow, it's very close to what our friends Lee and Quan said, by the way, which is kind of funny. Obviously, I made it such that it's never right, but you know, it's interesting. Okay, so this was a long question. We took 40 minutes to do this. Like we went through it, but this is quite literally, I'll zoom out a little bit, as hard as it gets. It's with the most steps possible. It's really as complicated as it gets. I mean, we literally had 5 steps to this question, but we were able to go through. Now, let me ask you this. Although unlikely that you'll see this on your exam because it mixes everything that you need to know for chapter 5, we had a normal annuity. Then we had some simple discounting. We had a growing normal annuity. Then we had a perpetuity, but not only that, we had a perpetuity with missing cash flows. Okay, and then we had to do some effective rates computations. This is a very busy question. I feel like you went through this one pretty well. So I'm going to ask y'all, do we have any questions, and how comfortable are we if we were unfortunate enough to see this on the exam? Which I don't think, but still, how do we feel overall? Good? Are we okay? Like, is this fair? Yeah, I think it's okay. All right. Okay, okay. Any questions before we move on? What's up? What's your question? No worries. I got you. So what you're gonna do, you begin with, I'll highlight these in green. You have this amount here, 5,095. You're gonna do this minus 884. Okay. Quick math, I should give you like 41 something, like 4,180 or something like that. I could be wrong. So you minus this amount, then you minus this amount, and then you're gonna divide by this amount. And that's gonna give you 114. It's just the orders of operation. Yeah, orders of operation. All right. Thank you. Oh, merci beaucoup. Yeah, thank you, Elizabeth. That's exactly how you'd go about it. Thank you. That's another way, a simple way actually to talk about it. I'm just used to my Sec 4 math. It's the same setup, one by one, step by step. But cool. I think this was good. Any other questions before we move on? Like it's a tough one, so I'm okay with answering other questions. Okay, feel like we're good. Let's move on. Allons-y les cocos. So now we're going to jump into some equity valuation. This is where this is another hard one, but it's kind of straightforward. I may have done it with one of the students here. It's very straightforward though. It's honestly quite a good time as well. So we're going to go about doing that. I'm just getting my solutions. We take a little break at the same time. Cool. Alrighty, let's get into it. I guess I'll start now. So question 3, we're dealing with some equity valuation, some common stock equity valuation type of question. And this one's interesting because we're solving for the present value, but through 3 different sections, okay? But what's interesting is that this is actually not that hard when you think about it. We just gotta be rational. We gotta put stuff in perspective. Now, on the exam, what I want you to remember is that if you see something like this, just paid, or if you see dividend, or if you see something of the sort of like, I'm kind of skipping a few steps, you see the growth rate, if you see anything like that, I want it to be clear to you that you're dealing with a question that is all about the constant growth DDM, okay? So when you have something like that, there's only one formula to use, right? And that formula could be written in a bunch of different ways, but still, the formula remains to be one and literally unique formula. It looks something like this. P is equal to D0 times 1 plus G over K minus G. The reason why I'm writing this formula on screen is because, once again, it's like with chapter 5 when we were using our flowchart. If this is the only formula we have, we do not need to look for anything other than that. We don't care because that's the only formula we need, okay? It has to be painfully clear to everyone here, all right? So that's kind of just the perspective that I want us to have moving forward. Now, obviously, this could be written in a bunch of different ways, but for now, I think that'll be fine. So we have Onitsuka Tiger, which just paid a dividend. So if it just paid a dividend, where is this on our timeline? It just paid a dividend. It's like we're soldiers at this point. We know exactly where this goes. All right, if you see this on the exam, you know that this is as at D0. So we would have D0 right here. We could write it as being, I guess, D0. We would put 3 0.5 right here. That's amazing. Now, we're telling you the growth rate in dividends is expected to be a constant 5% per year infinitely. So we're telling you that this is going to grow by 5% every single year forever. Okay? So we have our G. Literally, this is telling you, hey, every year we're going to grow by 5%. This is very important. Okay? Every year. This is exactly what we're telling you. Alrighty? Then we're telling you something really interesting. We're telling you that investors will require a 14% return on the stock for the first 3 years. Okay? For the first 3 years, investors will require K to be equal to, all right? They're going to require K to be equal to 14%. Okay? Now, I want to just continue on a very important note, and I hope you kind of see it by now. Typically, these questions on your exam are kind of straightforward, right? They'll take a big problem, and within this big problem, they're going to divide the topic of time value of money into different parts, right? So they're going to break down the problem into a bunch of different formulas that you need to use. So as we saw in the last question, we have part 1, part 2, part 3. Sometimes they're crazy to give you a part 4. Sometimes, they only have 2 parts. But that's really the only nuance, the only ambiguity or difficulty to your whole exam Comp 308 process. You want to be able to look at these big problems and to understand what are these little bite-sized pieces that you have within the question. All right. And a really good way to be able to identify that is always to look at the years, right? When they tell you something as like flagrant, as blatant as this, if they say something to you that's a little bit like this, that literally says, hey, for the first 3 years, okay, you're going to have something. You should know that that's already one part of your question, and that's its own individual part. If they give you something as blatant as saying for these amount of years, okay? So questions will always kind of break themselves out or like divide themselves into categories by the number of years that they're associating themselves to. In this one, they're saying for 3 years, we have this happening, okay? I kind of went on a rant, but I just want that to be clear, that it's very easy to break down these questions into pieces because they're always defined by the number of years they're occurring, right? It could be forever, it could be for 2 years, 3 years, etc. And in this case, it's also followed by a 12% return for the next 3 years. So come on, at this point, it should be pretty evident that this question already has 2 parts to it, au minimum, right? It has another 3 years at 12%. That's pretty interesting. And then they're also telling you that after that, they're going to want a 10% return thereafter. So after 2-3 years, so after 6 years, they're going to want 10% return thereafter. So really, the whole spiel was for me to tell you, hey man, in a question, if they divide sections by the amount of years that something's going to happen, it's really important for you to understand that we have 3 parts to the question at the very least. So let's try to put everything that we just said onto our timeline, and we're going to do it in a nice way. All right. So obviously, we're going to have T0. This is where D0 occurs with 3.5. We have year 1, 2, 3, 4, 5, 6, 7, 8, all the way to 10. Right? And we're just going to quickly identify the different pieces to our question because it's just going to be good practice, and you'll understand why this matters so much in just a bit. So in this question, we're telling you, hey, the first 3 years, you could expect the required rate of return to be a specific amount. Okay? You could expect the required rate of return to be how much? What is our required rate of return for the first 3 years? Our required rate of return? Yeah, it's 14%. There you go. Not our growth rate, just our required rate of return. What we're telling you is that we could break down this question into its 3 portions. right, into these portions that are all different based on the required rate of returns. You want to look for what's different. In this case, the segment that is different is the required rate of return. Okay. Now we can look at the next step, which is essentially T4 all the way to T6, the next 3 years, right? We know that K will be equal to 12%. Okay. And then we have the last section. Like that, all the way forever. That says K is equal to 10%. Okay. Now, before we make the next step, so far, do we understand what I put onto the timeline? That we have different required rate of returns for different times, and I just want to be able to highlight it onto our timeline. And the reason why this is important, okay? The reason why this is important is because, once again, when we're dealing with our constant growth DDM, when we're dealing with the equity valuation chapter, especially for the common stock portion, there's only one real formula that we need to use, which is P0 is equal to D0 times 1 plus G over K minus G. And a big portion of this formula, once again, of the 3 variables you need is K. But the thing is, in this question, we literally have, all right, 3 different Ks. So let me ask you this. Would it make sense to use 1K for the entire question? Would that make sense? Would it make sense to use just 1K for the entire question if we have 3 different Ks? No, it wouldn't make sense. That would make absolutely no sense. So already there, you need to understand that because we have 3 different Ks, that would require us, exactly, we have to do this equation 3 different times. Amazing. So that was my very long, too long way of explaining why we want to break this down into steps. So as for usual, in this case, our rate, if they say nothing other than like, if they just give you a rate, you just want to assume, Elizabeth, now you're onto something. Exactly. We're going to talk about that in a second when we do like part 2 and part 3, but that's very smart. What discount rate will you use, right? When you're kind of going forward, backwards? Well, you're going to use a discount rate that is covered during that timeline, right? So if this brings you to present value here, then you're going to use a discount rate right here. And if the present value of this perpetuity here brings you at T6, well, for 3 years, you're going to use this discount rate. And then you're going to use, for another 3 years, a discount rate here. That's just me quickly giving you a spiel. We're going to talk about it more in detail when we go about it. But very good question, Isabel. You're forward thinking. That's amazing. So we can begin with part A, all right, which is right here. So we're going to begin with part A. All righty. So part A, or part 1, I guess. So for A. All right. So once again, we know our formula. It should be clear by now. It's P0 is equal to D0, 1 plus G over K minus G. Now, what we're going to do, as we always do, is we're just going to identify our stuff. Now, obviously here, you can kind of just use D0 if you want. It actually works pretty well. We're just going to identify everything. So what's our D0? Somebody tell me in the chat, what is our D0? 3.5. Hell yeah. What's our K? 14%. What's our G? You should remember this by now. Yeah, 5%. Okay, so what you're going to do is you're going to plug all of that into our formula, and you're going to tell me what is our present value. We'll wait for one more person to do it. Oh, my bad. By the way, I always make this mistake. That's crazy. I'm so sorry, y'all. I'm so sorry. I always make this mistake. This happens when I get tired a little bit. I'm so sorry, everybody. That's a bad mistake. But it's on me. This is why it's very important to always remember that in equity valuation, okay, in equity valuation, we're really only dealing with chapter 5, right? We're dealing with a very specific case of chapter 5, okay? And you'll see why I'm a fool. I'm a fool in a tutor's disguise. But this right here, what it is really, it's a perpetuity formula, right? This is a perpetuity formula. And a perpetuity formula means that the cash flows will occur forever, okay? If you're dealing with a perpetuity formula, this means that cash flows are going to last forever. So you need those dividends to last forever. They need to occur forever and that growth rate to maintain forever and that K to be the same one forever. But the thing is, let me ask y'all this. That's all me. T1 to T3. I don't know about y'all, but that's not forever. That is not forever. That's only for 3 years, right? So it would make no sense to use a perpetuity formula for something that lasts only 3 years, right? It would make no sense. I guess I tricked y'all. That would be what a smart person would say to cover their mistake. But that's just me kind of being a little bit tired. But no, what I really want to say here is that because K equal 14% only lasts from T1 to T3, we can't use a perpetuity formula. It wouldn't make sense. And for that reason, what other formula, right, that deals with something that's happening for a definite amount of time, that's happening at the end of the year, and that is a growing set of payments? Exactly. We would use, in this case, the growing annuity formula, right? So essentially, you would want to use this formula right here. And I'm so sorry about my mistake. That's such a bad mistake. We may have to take that break a little sooner. I'm getting dehydrated or something. Yeah, no, for sure. No, 100%. You're literally like, what is going on? But no. Thank God I cut it quick because that's hilarious. But yeah, in this case, if you plug in everything, you're going to get your present value at 8.93. Okay. Now, I'll highlight this. I'll highlight in the same color. What we get, obviously, is going to be our present value. This is our present value at 0, right? Because we're only going 1 period back. Okay. So far, so good. Now, before we move on into the second step, I just want to kind of take a step back and just make sure that we're all okay. Obviously, I made a mistake, but do we all understand what was the right thing to do? And are we all like on the same page now? Is there any questions? Are we all okay? Good? My bad? Okay, awesome stuff. Now we can move into part 2. All right, my mistake once again, everybody. So we can check part 2. Now, part 2, we're going to do the same little idea. We're going to solve for B. And we're going to not make the same mistake, right? We're not going to make the same mistake. And we're going to acknowledge that obviously part B, like B, that section, only lasts for 3 years. So it wouldn't make sense to use a perpetuity formula. A perpetuity formula can only be applied for something that will last forever. And in this case, we know this lasts a definite amount of time, 3 years. So for that reason, we're going to use what type of formula? Put it in the chat. If you were to use the flowchart, we would use exactly the growing annuity formula. All right. Obviously, not going to write it again, but I'm just going to ask y'all, what will be our payment then? What will be our payment? What will be our K? What will be our G? And what will be our N? Our N is obviously going to be 3. Our G is obviously going to be, what was it, 5%. And our K will be 12%. But what will be our payment? I need everybody to tell me here. What's going to be our payment? What is our payment right here? Exactly. Very solid stuff. Okay, now for everybody that didn't see it, we have our dividend at 0. And we know it grows by 5% every year. So you have to grow it once, twice, 3 times, and then 4 times to get to D4. So what you could do is simple D0 times 1 plus G to the power of 4. And that gives you essentially something along the lines, if I'm not mistaken, of 4.25. Something like that. And if you plug that in, you're going to get your present value, right? You're going to get your present value, but that present value will be right here. That's where our present value lies. Okay, so if our present value is at T3, and we know it's equal to 10.69, we obviously need to discount it. We need to discount it. But the thing is, let me ask you all this. If we're discounting it from here all the way to here, what is going to be our discount rate? What will be our discount rate if we're discounting it within that period of time? I need everybody to put it in the chat. What will be our discount rate? What will be our discount rate if we're now at T3? I only have 2 answers in the chat. One says 14%, the other says 12%. What will be our discount rate? And if I'm asking you the question, it's already probably a hint to what the actual answer is. But what is the discount rate? I need more people to give it in the chat. Marianne says 12. One more person. What is going to be our discount rate? The answer is actually going to be 14%. Our discount rate is going to be 14%, right? Because look at this. We are at PV3. And we know that from T1 all the way to T3, the discount rate, as you can see, is equal to 14%. Okay? The interest rate that people would expect from year 1 all the way to year 3 is 14%. So when you are discounting your cash flows within that period of time, between T1 to T3, it only makes sense to use the K that exists during that time. What was the value of N for part 1? Like right here. This was, here you had 3. Here you had 3. And here, because you're at PV3, you're at 3 as well. Obviously, we didn't have to discount this one because it's already at PV0. But for part 2, when we plug our stuff in within our formula, we get back to PV3. Okay, we get here. Now we need to discount that all the way to PV0, right? We need to discount that all the way to PV0. So in order for us to do so, we got to use our discounting formula right here, with N is equal to 3, our PV3 being this right here, and our K was the only like nuance, right? Marianne, is that okay? Did that help? You got a different answer for this one? What did you get? What was your payment? What was your K? What was your G? What was your N? Could you put that stuff in the chat? And I'll let you know. What do you plug in? And in the meantime, while you plug that stuff into the chat, I'm gonna ask the others, do we understand K 0.14, payment 3.5, and 3? There may be a small, oh yeah, payment 1, by the way, obviously you're taking this number here. So payment 1 is gonna be D0 times 1 plus G. Okay. But let's move on to this part right here. Are we all okay with K being 14% right here? Yeah, because obviously we're in this period of time. Okay, cool. So now we have essentially PV0 being equal to 7.22. All right, that is our PV0. And now we could actually start using our perpetuity formula for part 3. Solve. Proceed. All right. So here we have C. Now, what's really dope is that when you use a timeline, it kind of makes sense. It kind of works better for us. In this case, we know from T7 onwards, like forever, we know we're going to be dealing with a perpetuity because these dividends will be growing at a constant rate forever and 10% will remain forever. So in this case, we're actually allowed to use our perpetuity formula that says the following, that P0 is equal to D1 over K minus G. You could also write this as being P0 is equal to D0 times 1 plus G over K minus G. It's really up to you. They mean the same thing. Okay? So with that said, I'm just going to ask you a few questions super quick. What will be essentially our payment right here? So D7. Somebody tell me in the chat, what is D7? You guys are awesome. It would essentially be D0 times 1 plus G to the power of 7. So that's really good. And then we would also have our K. What is our K? Somebody tell me in the chat. Another person, just for fun. Thank you, Shane. Hell yeah. And our G obviously remains at 5%. So tell me, what is the present value of this little formula here? Okay, so I think we could all agree. If you take D7 over 10 minus 5%, like what do you get right here? That's what I want. Not the final answer, if anything. If you plug this in within your perpetuity formula. Okay, awesome. So we got 98.48 slash 98.49. Okay, so we have 98.49 right here, such that our present value at 6 will be 98.49. Now, we all know the spiel at this point. The value at PV6 is not PV0, so we need to discount it back all the way to PV0. Now, the thing is, we're discounting this PV6, right? This value through two different states of the economy, through two different required rate of returns. So in order for this to make sense, we need to discount it while using K equal 12 all the way to here, so for 3 periods. And then we need to discount it again while using K equal 14% to get to PV0. Okay, so we got to discount this twice while K is equal to 12%. And then when K is equal to 14%. Obviously, we're going to discount it for 3 years here. We're going to discount it for 3 years here. And that's going to bring us all the way back to T equals 0. Does that make sense to everybody in the chat? How we're going to discount it for 6 years, or we're going to discount it in buckets? Because one segment, T4 all the way to T6, K is equal to 12%. So for that period of time, we got to discount it by 12%. Once we got through that period of time, we can now move on to the other period of time. It was 4.924, exactly. Once we get into the second period of time, which is T1 to T3, where K is equal to 14%, we're going to discount it for 14%, and that's going to bring us to PV0. All right. So with that said, let's do just that. So we know that PV3 will be equal to PV6 over 1 point, I believe, what was it, 12%? To the power of 3. Can somebody tell me what PV3 is equal to then? I need a few people to put it in the chat. A few people to put it in the chat. What does that give you? There you go. Thank you so much. There may be like a small rounding error, but on the exam, just make sure not to keep your decimal points up until to the end, and you should be fine. So that's PV3. All right, so we could go ahead and kind of highlight that right here. So we have our PV3. Okay, so we have that now, and now we got to discount it all the way back to PV0, such that we know that PV0 will be equal to PV3 over 1.14 to the power of 3. What is that going to give you? Amazing. Okay, so are we done? Is the question over? I don't know. Are we done? Do we still got more to do? What do y'all think? I need a few more students to give it a shot. What do y'all think? Are we done? Elizabeth says no. Elizabeth says we need to. Unfortunately, no, we're not done. Exactly. We got to do one more step. And that one more step is simply really important to remember. The value of a dividend or of a stock, really, the value of a stock, present value of a stock, is equal to the future discounted cash flows that you could provide, that you can make on that stock. So what you would do is simply do P0 is equal to A plus B plus C, such that you would have 8.93 plus 7.22 plus 47.32. And that would give you, I need a few people to write it in the chat. What does that give you? Hell yeah. It gives you 63.47. And that's how you go about it. So this question, I mean, other than the little mishap and the little rant at the beginning, I feel like it went okay. You know, I feel like it wasn't too bad. Yeah, sure, Willie, no problem. So the present value of part C, okay? This is how we're gonna go about it. We know, and you're gonna say yes in the chat for every portion, and I'm gonna highlight this in red or in green, okay? We know that we have our payment, which is D7, and D7 is equal to this. D0 compounded, I mean, not compounded, but that grew for 7 years, all right? And that gave us 4.924. That's your D7. And you could plug that in within your formula right here. K minus G, we already have these numbers. So we have our K, which is 10%. We have our G, which is 5%. You plug all that good stuff in, and you're gonna get your PV6, right? You're gonna get your present value at year 6. That's equal to 98.49, right? But the thing is, year 6 isn't year 0. So we gotta discount this stuff. However, we have 2 different periods that we need to discount through. The first period from T4 to T6, where K is equal to 12, and then the second period from T1 to T3, where the discount rate is 14%, right? So what we did is we took PV6, we discounted it for 3 years, right? For T4, T5, and T6, with discount rate being 12%. And that gave us this amount. So that gave us essentially our present value 3. Present value 3 is right here, okay? Right here. Now, obviously, that's still not equal to PV0. So we need to discount this for another 3 years. However, these 3 years, they're facing a different required rate of return. They're facing a required rate of return of 14%, right? For T1, T2, and T3. And for that reason, we're going to plug in PV3. We're going to discount it for 3 years, right? But add the required rate of return for those 3 years, which is 14%, okay? So that being 47.32 is your final answer for C. Then we need to add all those bad boys up together. And that's going to give us, obviously, our final answer. Did that help? Did that give you context? I think, I hope. Any other questions about that, if anything? Okay, good. What about everybody else? Like overall, if you see this on the exam, do you know what to do? Do we have any questions? Really, the nuance here, it's understanding that they gave you cues with the amount of years of how you had to divide this onto your timeline. And then you just got to plug and play every single time. And you got to remember, the discount rate is always related to the amount of years that are attached to that discount rate. So I just got to keep that in mind. Okay? So let's move on to the next question. We got more to do. Let's, where are we now? This one's pretty straightforward. This one's very easy. So we're going to run through this one. And there's, yeah, it's fine. So question 4, this relies essentially on the portfolio theory chapter. It's kind of straightforward. And we'll kind of run through it together just to make sure that you don't have any questions. It should be fine. Now, on exams, they like to create questions that are super wordy, super annoying, and super long. This is exactly an example of that. But we just want to highlight a few pieces. We want to highlight the important pieces of information, and then we want to figure out what's our mission. What are we solving for? So let's read this question together. You're currently owning shares, or you currently own shares in Microsoft. Your friend calls and recommends buying shares in a small capitalization fund managed by NVIDIA. Your friend says that this fund will provide significant diversification benefits for your existing holdings. She gives you the following stats based on the performance of the two funds over the last year. Assume that you have decided to invest in a combination, okay, of the Microsoft stock and the risk-free asset. So let me ask you this. Where are we investing our money? Somebody put it in the chat. Where are we investing our money? According to this question, according to what we just highlighted. Where is our money invested? This should be clear. Where is our money invested? Where did we put our money in? Where did we invest our money in? It's highlighted in yellow on the screen. Can somebody put that in the chat? No? Yeah, Microsoft. Okay. A combination of Microsoft and what else? Microsoft stock and the risk-free rate. Amazing. Okay. So this is pretty important. There you go. Microsoft and the risk-free rate. I hope there was no answers because it was so obvious. Okay. But the reason why I'm saying this is because if we're only invested, if that's what they're telling you in yellow, hey, assume that you have decided to invest in a combination of Microsoft and the risk-free asset. Does that mean that we invested in NVIDIA? Did we invest in NVIDIA if we're telling you that we just invested into these two things? Yes or no? No, we did not invest in NVIDIA. So what I'm trying to tell you here is that everything that was said from this line to this line was all fluff. It literally meant nothing. It says absolutely nothing to what you need to do in this question. Okay? That's what they could do on an exam. This literally, it means absolutely nothing to us. Okay? I just wanted to make that super clear. That all of this actually does nothing for your problem. Because they told you right here, hey, we're just going to assume that you're going to invest in these two stocks, Microsoft and the risk-free assets. So these two assets. Okay? So that should be pretty clear. Now we're asking you, what fraction of your wealth should be invested in Microsoft so that your portfolio earns a target return of 22%. Okay? So what they're telling you is they're asking you for essentially, how do we get to an expected return of our portfolio that is equal to 22%? All right? How do we get there, and how much do we need to invest in Microsoft? So what will be our weight in Microsoft? That's what we're asking you, okay? But before we take the next step, I'm just going to highlight a very important formula for everybody here, okay? For you to find the expected return of your portfolio, it's actually really easy. And assuming that you're only going to see two stock portfolios or two asset portfolios on your exam, so they only have two items, it's very, very simple to do. What you would do is simply do the weight of stock or asset A times the return of asset A plus the weight of asset B times the returns of asset B. This is what we call a weighted average sum. And let me give you a really good example. Okay, let me create the example. Let's do this easy. This is something that we could all relate to. Let's say COM 308, okay? COM 308, you only had two exams. You had the midterm and the final, okay? The midterm is worth 25%, and the final is worth 75%, okay? On the midterm, you got 93%, okay? Actually, I'll make it easier. On the midterm, you got 90%, but on the final, you got 60%. I want to ask y'all, what is your final grade? Somebody tell me in the chat, what is your final grade in the class? Somebody tell me, what is your final grade in the class? I need a few people to write it in the chat. Okay, good. So your grade is simple, and everybody got this, right? Because it's obvious. What you did is you did 25% times 90%, right? Then you added that to 75% times 60%. And that gave you essentially what you got in the class. Everybody got to the answer that it was 67.5%. What we just did there, this very rational and easy thing that we could all do since the age of like 5, is a weighted average sum, right? We had essentially invested our grade into 2 different exams. These exams with different, essentially, returns. And with that, we get the total return, the total grade in that class. So what we're doing here is we're telling you, we're doing the same thing for the portfolio. The portfolio, this would be essentially, the returns would be your grade, right? This would be your grade. And essentially, the weight would be essentially literally the weight of that exam. And that's exactly what we're doing with a portfolio. We're just saying that, hey, you took 2 exams with 2 different grades, right? And these exams are worth different points. And when you put them all together, what would be the grade of your portfolio? That's the same rationale that we're doing here, okay? And let me ask you a question. Obviously, because we only have 2 exams here, right? Could one exam be worth 120%? Somebody tell me yes or no? No. And could one exam be worth 0% and the other 100%? Is that possible? That can happen. Like that you only have 1 exam technically? Yeah, 100%. So technically, the weight of an exam or the weight of a stock could only be technically, theoretically, well, not really, just technically, between 0 and 100, okay? So that's really important to understand. So we want to figure out the span of the weights of your portfolio between 0 and 100. I'm going to ask you another question. If I tell you this, if I tell you that the midterm was worth 30% of your course's grade, what is your final worth? How much is it worth of your total grade? 70. It's worth 70%. And everybody here, you guys, you know what you did? You did this. You did 1 minus 30%, and that gave you 70%. So with that in mind, what you could say is you could say that if weight A is equal an amount, call it, I don't know, like a random amount, 25%, we could say that weight B is equal to 1 minus 25%. In other words, it's equal to 1 minus the weight of A. So right now, I'm just throwing at you a few little pointers and a few like I guess logic, not only for the exam, because they may throw that like verbiage, that type of wording at you, but also when you move on to the next chapter, these little concepts will be extremely, extremely, extremely important, okay? So with that said, what we're asking you here, right? If we go back to actually what matters, we're telling you, hey man, if we know that the return of a portfolio is equal to the weight of A times the return of A plus the weight of B times the returns of B, and we know in the question that we have the return of the portfolio we want, we're seeking essentially 22%. We have the return of A, which we could call Microsoft if we want, which is 20%. And we have the return of B, which would be the risk-free rate, which we know is 8%. And we want to know how much has to be invested in Microsoft and technically also in the risk-free asset for us to earn this as our return of our portfolio. So what you can do is actually pretty interesting. You could do the following. It's a very good trick to use. You would say that 22% is equal to essentially the weight of A times 20%, right? Plus 1 minus the weight of A times 8%. Now you're probably like, wait a minute. Let me just ask you this. Are we okay with what I just did here? Because of what we just explained beforehand? That because we know that it makes sense, right? Because you could only be 100% invested into something, by definition, this has to be 1 minus the weight of A. And the reason why we did that, by the way, the reason why we did this is because why would we want to deal with two missing variables? I don't know about you. I have a whole degree and I still have some problems dealing with two missing variables and doing it like super quick on an exam. So we're going to make this easier for us and we're going to have only one missing variable, which is essentially X, because this would stand for X as well. So now we're only dealing with one missing variable and it becomes really easy to solve for that missing variable, which is the weight of A, in other words, the weight of Microsoft, or X. So I'm gonna ask y'all, what is X? What is the weight of A? What is X? What is the weight of A? If you were to plug all of this stuff in into your formula, I mean, not into the formula, but just to find the answer. I'll do it with y'all then, just to be sure. So we know that 0.22 is equal to 0.2 x plus 0.08 1 minus x. Okay, that's what we know. So because of that, we could actually get something pretty interesting. Let me make sure that this makes sense. So you'd have 0.2x plus 0.08 minus 0.08x. That's equal to 0.22. Then you can subtract that. Ah, there you go. It's okay, Elizabeth. It's fine. It's fine that it gives you a number that may not make sense. It's actually intended to be the case. Right? So everybody, can people tell me what did you get for X if you follow my steps? It's just simple algebra. And you may get an answer, by the way, that's bigger than 1 or smaller than, technically, if you were solving for the other one. But you may get a number that's bigger than 1. So everybody here, other than Elizabeth, did you guys try this? What did you get for X? Well, you got 1.16. Yeah, exactly. So you get X is equal to 1.16. You get X is equal to 1.16. This is akin to saying that the weight in Microsoft is equal to 116%. What is even happening? How does this even make sense? How do you even get something that's above what we said, right? The piece of the pie, which was 100%. How can it be bigger than 100%? Well, exactly. The way could be bigger than 100%, and this is something that you'll look a little bit more in the next chapter, is if the weight of the risk-free rate is equal to minus 16%, such that both weights, the weight invested in the portfolio, which is weight M plus the weight of RF, is equal to 100%, right? Because we know that it cannot be more. So you would do 116% plus minus 16%, and you'd get to that number. What this is representing is essentially saying, and it's not too important for now, but this represents this idea of short selling or like shorting a stock. So you're borrowing money with the risk-free rate, and then you're investing elsewhere. But you're investing in Microsoft in this case. And like that, you're able to get returns that are bigger than the individual returns that you have right now. Does that matter? No. What you want to know is that on an exam, you may have to do something like this. And you may have to get a return that's kind of strange, and that may like put you off. And it's totally fine that that's the answer. Okay. So it's not a very hard question. You just need to solve for X. And it's possible that the weight of the asset is bigger than 100%. And that would mean that the weight of the other asset will have to be smaller than 0. So the answer would be 116% in Microsoft, and then minus 16% in the risk-free asset. So what fraction of your wealth has to be invested? It has to be invested at 116%. Okay? Because you're breaking, essentially, well, let's break it down to 2 steps. No matter what, the answer would be what you get with weight with this number here. Okay, that's your answer. But remember the rule of like it cannot go over 100%. And the reason why it cannot go, and the reason why we're still like following that rule is because we are invested at minus 16% with the risk-free rate. Okay, here it's a minus. So we're invested at minus 16%, and that's why we could be invested at 116% here. Do you need to understand a whole rationale behind for now? No. You just want to be able to plug this in and to understand that sometimes the weights may be one positive number and one negative number, okay? And when you added them together, you're always going to get 100%. Because once again, it could only go up to being 100%, the combination of the 2 assets, but one individual asset could be equal to something bigger. So just to tie a bow on this, because I feel like I'm talking a lot, and it's okay, because right after this, we're going to have a break. But I want you to know, and we'll give you an example. Okay, so this is the portfolio. Your wealth could only be 100% invested. So you could be invested into, let's say, for a 2-stock portfolio, into A and B. All right. So I'll give you guys a few examples. If we're invested 70% into A, how much are we invested into B? Can somebody tell me? 30%. Amazing. Right? Because we want this always to be equal to 100. If we're invested at 89% into A, how much are we invested into B? 11%. Amazing. If we're, no, it's 100% correct. Like there's a few decimal points. Like it's supposed to be 6, yes, like, yeah, and then a 7 here if I'm not mistaken. But the answer is 100% correct. But now the next step I'd like to do is if we're 140% invested into A, how much do we need to be invested into B to be able to get 100%? Minus 40%. There you go. And one last time, if we're essentially 102% invested into B, how much do I need to be invested into A? Minus 2%. Okay. So the general consensus here is that you want to always make the total percentage of your wealth equal to 100%. But A and B, they may be negative, right? One may be negative and the other one will have to be positive to counterbalance it, and vice versa. Or they could both be positive. But in some cases, like in our example, yeah, exactly, Waleed. Exactly. So you're borrowing with the risk-free rate in order to short with the actual like stock asset. I'm not going to explain too much about it, but this is what you want to understand, is that because you're borrowing at the risk-free rate to invest in Microsoft in this case, you are able to be negatively invested in the risk-free and over positive invested into Microsoft. So in terms of just, if you see this on an exam, would you know what to do? Could you answer yes or no in the chat? Do we have any questions? Yeah, it has nothing to do with it because we're solving for the expected return. We want to know how much to get this amount. So this has literally, it's so much fluff. I saw this on an exam and I was shocked. You know, I was like, why? But a lot of it is just fluff. You only need like 2 things. So on that note, what we're gonna do is we're gonna take a well-deserved 15-minute break, and then we're gonna jump right back into solving another missing cash flows question. And yeah, and just keep on grinding and getting the most out of this as we can. So we're gonna get back here at 7:20 p.m. Actually 7:21, because now it's 7:06. So 7:21 p.m. All right. I guess I'll just rewrite it. And of course, I'm gonna give you, in the meantime, the blessing of the Japanese musics if you're still in the chat. So see you in 15 minutes. We're gonna come back into it strong. Okay, no problem. See you. Okay, we're back into it. We lost a few in the cracks, but I mean I can't blame you. It's a lot of work. So that's why you know, there's the recordings and all that good stuff. I went for a walk, so I feel great right now. It definitely did help. So let's get into it. And listen, there may be like a few questions that we don't go through like at 9 o'clock on the dot, but I'm honestly pretty okay with going over. And all of you obviously could leave at 9 and don't, you may have like stuff to do. You know, it is still like what, Thursday? No, what day are we? Yeah, it's Thursday. So I'll stay. You know, I'll try to get through all the questions, including those of yesterday. And like that, when you review this recording, you'll have like everything in one. So that'll be super helpful. And on that note, let's begin question 5. Let's go with that. It should be pretty okay. Honestly, it's my first time doing it. I'm not even gonna lie. I made it when I created this document. It never existed. I didn't have like an interactive prompt for it or whatever. So we'll go through it together. But it's very similar to what you've seen in the last like 2 years of exams for Comp 308, in the sense that you have missing cash flows. You need to group these payments together. You need to visualize it, and it's only given through a text prompt, right? So we're gonna work through this together. It should be pretty fun. Or fun is a big word there, but it should be pretty interesting if anything. So let's go through it. So once again, flowchart question, missing cash flows type of question, a few steps to take. So the present value of the following cash flow stream is 3,569.17. So we have our present value right here. We already know that. That's really cool. So technically, we could write our present value right here if we wanted to onto our timeline. And we know that this is going to be discounted at 7.25% compounded quarterly. So let me ask you this. This figure right here, what is it? Is it a QR? Is it EAR? Is it a quoted rate or effective rate? Exactly. This is our quoted rate. It's 100% quoted. And we know this because right after they tell you, hey man, this is compounded quarterly. So we need to account for that, and we need to solve for our EAR afterwards. It's going to be super important. Okay. So what is our EAR? And we're telling you that, hey man, we're going to have this type of pattern from what it seems. We're going to have 0.5x at the end of year 1, okay? 0.5x at the end of year 1, 412 at the end of year 2, and 2.4x at the end of year 3, and 175 at the end of year 4. So we have one heck of a timeline to deal with, right? But what's really interesting is that they're telling you, hey, this pattern of payments will continue in perpetuity. So what we just highlighted is going to occur every 4 years. That's very, very, very important. Okay, every 4 years. So we're going to have a pattern. Okay, we're going to have a pattern here. So on an exam where you would see something like this, I think it's crucial to really identify everything as we did just now, and then place it in your timeline. Make this easier for you. So knowing how I like to do things, is exactly what we're going to do. We're going to make our timeline, and we're going to let it work for us. Now, if you're a pro, you don't necessarily need one, but it's definitely going to help us kind of flesh out a few topics right now. So we know at T1, we have 0.5x. Then we know we have 412. Then we know we have 2.4x. Then we know we have 175. However, we know that this process is going to repeat itself again and again and again. So we have 0.5x here. We have 412 here. We have 2.4x here. We have 175 here. Then we would have, once again, 0.5x and then 412. And obviously, this would happen forever in perpetuity. Okay, so in perpetuity, this would occur. All right. Now, you should notice by now, because you've done countless questions with me. I think we're at like 4 at this point, at the very least, that we did together. But when you see 2 things, right? When you see a set of cash flows that are visibly, right, happening again and again and again for a specific amount of time, and they span a few years, you know to group them already. Okay, that's the first thing. You already know that. To make it much easier for you, to make the perpetuity formula much easier to play with, to do things with. So in this case, we'll kind of visualize it right now. We could quite literally group these payments, as you can see, as essentially larger payments. So what we did is that because we know that these payments, they span quite literally 4 years, we can make this easier for us, and we could say that we're going to create a large payment that's going to span essentially 4 years in itself. So as you can see, we could make these larger payments to make the perpetuity formula easier for us to play with. Because check this out. As much as we could say that 0.5x, 412, 2.4x, 175 happens every 4 years, we could also say something very similar and say that this type of payment that we grouped happens every 4 years. Instead of like saying 0.4, 0.5x, 412, 2.4x, blah, 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 we could just say, hey, payment 1 to 4 or payment 4 years happens every 4 years. Okay, so it makes it much easier for us to kind of work with our formula. Okay, so this is the first step. I believe that visualizing everything onto our timeline is the most important piece. Now, are we okay with that? Do we understand what I just did on the screen? How I decided to group this pattern into a larger payment that spans 4 years? Because we wouldn't be able to do these one by one. It literally would be impossible. You know, you wouldn't be able to do this an infinite amount of time to find the perpetuity value of every single one of them or the present value of every single one of these cash flows forever. It'd be impossible. Like, it'd be very hard. So by grouping them for 4 years, right, it makes sense. So that's the first step, okay? And just to do an active recall, our perpetuity formula really is the following, right? It's as simple as that. You could also write it as being, you know, Pn is equal to payment n plus 1 over k. But at the end, it's still the same thing. So we're only really looking for 2 variables. We're looking for payment and we're looking for k. Before we start looking at our real payment and what that would actually look like, it's very important for us to actually find, well, what are our k's, right? We need to find our k's here because we were only given our quoted rate, right? We were only given this amount here. So we're going to need to play with that and get our effective annual rate and then solve for our effective periodic rate. So we're going to call this essentially part 1, which is labeled as rates, solving for our rates, right? So right now we have our quoted rate and we need to get our effective annual rate before all else. So we know that we could get our effective annual rate with the following formula. So could somebody tell me, with everything that we have in this question, what is our effective annual rate? I'll give, you know, another person a shot to give it to try it as well. But thank you so much. That is most probably 100% correct. Just one more person to give it a shot. Thank you, Shane. Thank you, Elizabeth. Awesome. So now we have our effective annual rate. Now you may be asking yourself, well, listen, why is this our first step? Why is this our first step before all else? Well, the reason why that's our first step is because since our payments are going to group 4 years, okay? Since our payments are essentially grouping 4 years, well, we need to assess what does this mean for us? Well, even before that, Shane, the reason why we needed our effective annual rate is because we wanted to essentially figure out, well, what's going to be the compounding effect for every single one of these like cash flows occurring into our grouped payments. We need to figure that out. That's super important, right? So in this case, we know that our individual cash flows within our payment is essentially going to be compounding within our grouped payment. I don't know why I drew it like 10 times. So sorry. There you go. Give me a sec. I'm just trying to visualize something. There. So the reason why I got our effective annual rate, the reason at the end of the day is because I really wanted to showcase what we have going on here. Okay. The idea that within your payment that we created, this one payment that spans 4 years from T1 to T4 and essentially in perpetuity, these payments that we grouped have individual cash flows, right? This payment that spans 4 years has essentially 0.5x, 412, 2.4x, and 175. But these payments, these individual payments, I've been saying payments like 20 times already at this point, but these individual cash flows are going to essentially compound interest on their own within our grouped payment. So the one happening at t = 1 is going to compound interest for 3 periods. And the one at t = 2 is going to compound interest for 2 periods, as we see with the little red lines. And then our payment at t = 3 is going to compound interest within our payment for 1 period. And the cash flow at t = 4, well, it has no time to compound interest. It's happening at T4, and our payment ends at T4, so it has no opportunity to build interest, simple interest. So for that reason, that's why it's really, really important to get our effective annual rate. Okay, that's just to build out our payment in itself, and we'll dive deep into that. So also, the second step into our rates is to find our effective periodic rate, and that's going to be the rate that we're going to be using for our large formula. Is going to be the K to find the present value of our, essentially, of our cash flows. Okay, so in this case, what we do, if we know that we're going to be compounding interest essentially every 4 years, we need to get our effective annual rate to become our effective periodic rate. So for you to do this, it's very straightforward. You could do the following. And in this case, can somebody tell me what would be our M? What would be our M in this case? Exactly. Our M would be 1.4. So if our M is 1.4, and that's exactly what we're plugging in right here, can somebody tell me what is our effective periodic rate? I need one more person to give it a shot, please. Elizabeth's killing it though, 100%. I'll start writing it a little bit. So you'd have 1.0745 here. Does anybody else have an idea for what's our effective? Thank you so much. Thank you, thank you, thank you. Such that our effective periodic rate is equal to 33.2961%. Okay, so we got that out of the way. Now we know what's our effective annual rate and we know what's our effective periodic rate. This is a very important piece that we got right here because that's essentially the K that we're going to plug into our formula. That's like very solid. Congrats for getting that. This is the K for our formula to solve for X. So this is awesome. Okay. Now, the last step before we start actually solving for X is just doubling down on our payment. Okay. It's very important for us to do this. So we could go here and we're going to say part 2 is our payment. Okay. Now, as I said, our payment essentially is a grouped payment of 4 years. So we could say that we have T1, T2, T3, and T4, at which we know that we're going to have essentially 0.5x, 412, 2.4x, and 175. And as I mentioned earlier, we want to figure out, well, what's our payment? Unfortunately, payment can't be simply 0.5x plus 412 plus 2.4x plus 175. That wouldn't make sense. And the reason why it wouldn't make sense is because we're omitting a very core tenet, a rule, a biblical rule within the idea and the sphere of corporate finance. And it's the idea of a rational investor, a rational person would invest their money at any time where they have the opportunity to do so. So within our grouped payment, this means that, well, our payment at T1 would have incurred interest for 3 years. So technically, this payment that we have would be equal to 0.5 times 0.74495 to the power of 3. Okay? And then naturally, this one here at T2 would have gotten the opportunity to compound interest for 2 periods. Okay? So it would be 412 times 1.074495 to the power of 2. Now, I feel like you get the gist of it at this point. And that's why I'm going to test you a little bit, just to see if you're following. So our payment at T3, this one is going to be compounding interest for how many periods? I want everybody to give it a shot. Elizabeth says once. Willie says once. Amazing. Exactly. It's going to be compounding interest for just 1 period. So if we were to write it, it would be 2.4x times simply this. And then the final bit, the funny portion here would be, well, what about T4? Is it compounding interest at all? What? Yes or no? No. Perfect. So it would simply be 175. And that's going to be our payment, okay? It's a large piece. So what we're going to do, because we're efficient and we want to make this simpler for us, we're going to essentially simplify this into one number. And we're going to, oh, this one has an x, so we're not going to do that. That's just on me. Put an x here. So what we're going to do is we're just going to simplify this. So you're going to simplify this into one number that's like digestible. This one as well, the entire thing as one number that's digestible. This one we could leave as is. It should be pretty fine. So I would want you to simplify this formula for me, please. What would our formula look like then? What would our payment be? What is 1.074495 to the power of 3? That's essentially what I'm asking you. I want you to rewrite the formula. I could do it myself as well. So this one right here, thank you, Elizabeth. So we could simplify it further as being equal to this. All right. Then what about 412? It would be what did y'all get for this portion here? What is this simplified? Exactly. Well done. And then here, you could kind of simplify it already. It's just 1.074495 times 2.4. So what did you get for this one? Nice. Very well done. Plus 175. Because we're not absolute sociopaths, we could simplify this even more. All right? So how you would simplify this formula, just because you don't want to deal with big monsters on the exam, you could group your x's together. And you could group your whole numbers, your coefficients, I mean, no, your whole numbers together. So you can group these two together. So you can group yellow together and blue together, okay? So we're gonna begin with our yellow. What did you get for yellow? What is in front of our X? I got something slightly, Isabel, there's missing a 1, exactly. Shane is correct. So we would get something like this. And then for our blue, you would get, I could do some quick math. I can't even do math anymore. 650. I'm gonna say 650. What did you guys get for blue? Y'all got 650.67? Yeah, exactly. Hey, the quick math is working. Okay, so that's our payment. All right. Now, I know I was talking a lot. I'm sorry if I'm a little bit less like energetic as I usually am, but so far, are we okay? Do we understand what we did here? Do we understand how we got to payment? Yeah? Okay, cool. I'm happy about that then. Okay, so now if we go all the way back up, okay, if we go all the way back up, we have all the pieces. Yeah, no worries. We have all the pieces that we need to solve for our missing cash flows. But before we do that, we're going to explain the rates really quickly. So we're going to do as usual. I'm going to highlight some stuff in green, and you're going to tell me if yes, you understand, or no, you don't understand. Okay, so do you understand that we had our quoted rate and we had to make it an effective annual rate? Is that clear? Yeah. Did you get this number? Yes or no? No. So let me show you. What you do is you're going to do, what was the rate that they gave us at the beginning? It was 7.25. So you're going to do 7.25% divided by 4. That's going to be plus 1. That number to the power of 4 minus 1. Can you try that right now on your calculator and tell me what you get? You may have forgotten to put a percentage. That is possible. I make that mistake myself. You got the same one as us? Yeah? It's like, you got this? Okay, cool. So then it becomes extremely easy because you just plug that in here and boom, you get this answer right here. So I think you should be fine at this point because then it's just to the power of 4, right? Should be pretty straightforward. So I think we're good. So now that we have everything, okay, now that we have all the missing pieces of the puzzle, we could solve for our answer. So once again, we know that PO, so the present value, is equal to payment over K. So this means, all right, this means if we go all the way back up, 35969. I am absolutely dyslexic. It makes no sense. Yeah, so it's a very fair question, Elizabeth. It's a very, very, very fair question. Let me tell you why. In this type of question, where we simply have a missing cash flow and we already gave you, okay, and we already gave you the present. Let me just write this down. But so in questions like these, Elizabeth, when we already give you the present value, we already gave you that answer, okay? You simply want to assume that you got to solve for X. And the reason why is because if we had to play around, right, and we didn't know what this was, well, we would have to solve for the present value first, right? We would have to solve for that first. Then we would be able to figure out, well, hey, you'd probably be like at -2 for your PV. Then you need to get yourself to PV 0, and then you could try to do this portion, right? But in this case, we're saying, no, 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 don't even worry about it. We're already giving you PV 0. Now, all that you have to do is solve for the missing cash flows, okay? That's all that we want you to do. We're telling you that in this scenario, P0 already exists, and we simply want you to find X. And in order to do so, You just gotta put payment over K, right? And you gotta look for payment as we did right now, and you gotta look for your effective periodic rate. When you're dealing with questions that don't have missing cash flows and they don't give you the present value already, then it's a different beast. Okay. In this case, it's not the case. We're already giving you PV0. We're already giving you the amount that you need to equate it to, that you need to solve for. So you don't have to worry about discounting like 10 years backwards. I don't know if that gave you more context. I hope that helped. But I'll give you like the general rule. When we're already giving you this amount here, you already have it. You just got to plug it in and solve for the missing value. Alrighty. So in this case, we know what's our K. Our K was 33,2961. So all that you got to do now is you got to essentially multiply this number by this number and then solve for X. So once you've done that, once you multiply this number by this number here, you're going to subtract 650.67, and then you're going to divide it by 3.19, essentially. So I want to ask y'all, what did you get for X? What did y'all get for X? What do y'all get for X? Need a few people to try. Shane got 168. I mean, I could give it a shot while we're here. I mean, why not? Yeah, I got 168.08 as well. So maybe a small rounding error. But Elizabeth, as I was like doing that, I was also thinking at the same time. I think another pretty good reason why, and it's like I could do a proof. I'll not right now because I want us to optimize for time, but I'll do this now. I want to tell you now just for you to see. So remember, you're right. Remember how when before we would like group our payments, we would get essentially like way back. Remember how we used to do that? 100%. That's your question essentially. And then we had essentially PV minus 3, and we'd have to essentially compound interest all the way to PV 0 to find the actual present value. Now that's typically something that we need to do, and that's a very good like reflex that you had. I think one thing to maybe put into perspective, and I can do a proof later to see if I'm actually speaking some facts, but probably one of the main reasons, and I could be totally wrong, but I feel like probably one of the main reasons why we don't have to do that is because we are compounding interest forward through our payment. Okay? So through our numerator, through our payment, we're already accounting for the fact that we need to compound interest for 3 years. Notice how we're compounding interest for 3 years here, for 2 years here, 1 year here, and then nothing for the last year, because we're thinking forward and we're already accounting for the lost interest that was built, right? So because we already did that in our numerator, it would make no sense for us to do that again at the end, because then we would be compounding interest twice. We'd be essentially overstating the effects of the interest rate. So, and if you're like, think about it, when we do our previous examples, we would just have amounts here, and I hope you're still with me. We would just have like amounts like this, right? And then we would group them as a larger like entity. Then we would say, that's it. We don't do anything for the compounding effect that occurs within that entity. And then we divide it by the effective periodic rate. It gives us a value in the past, like way back. And then we decide to compound interest all the way to T0. But we did that in this question, okay? We did it because we already compensated for that by changing our numerator. by accounting for the individual compounding periods that each and single one of these payments would have. I don't know if that gave you context. I don't know. Maybe we could talk about it later, but it's the idea that like we already did it, so it would make no sense for us to do it again, like in math, in like real life. Anyways, overall, with this question, in terms of like steps, do we know what to do? Are we confident? Are we okay? Like, are we good with this? Does this make sense? Okay. All right. Cool. Let me just drink a little bit of water and we'll move on to the next question. Alrighty. So let's go. Question 6, amazing. Question 6 is a little bit like what we did yesterday. I just want to put you through the reps. You know, these are logic questions that you may see on your exam. In other words, they're curveballs, but it's really important for you to be able to go through them. So what we're gonna do is just that. Okay, so let's go about it and let's start the time. Alrighty. So let's start with A. At a 3% rate of interest, all right, at a 3% rate of interest, you will quadruple your money in approximately how many years? Okay. Now, there are 2 ways of doing this. One, by simply using your calculator, okay, where you would put your IY as 3%, you would put your N as what you're computing for, and you would put your PV at like $1 and your future value at like $4 and your payment at 0. And then you would just press compute for essentially N, right? That's one way to do it. Another way to do it is simply by just using math. So we know that the future value of something is equal to the present value of something times 1 plus k to the power of n. So what we want to figure out is we want your future value, right, to be 4 times your present value. So what you could do is you could use a random amount, for example, $100 as your present value, and that would mean that you would want your future value to be equal to $400, such that you would have $400 is equal to $100 times 1.03 to the power of n. And then you would obviously solve for n. That's one way of going about it. It's a very straightforward way. Obviously, this would require you to do a little bit of math, and that's totally fair. So if we want to simplify this, I'll do it quickly. You would have, 4 is equal to 1.03 to the power of n. And then what you could do is you could use our good old friends called log. And you would have something like n ln 1.03 is equal to ln 4. And then you would do n is equal to this over this. And that would give you your n. That's one way of doing it if you want to use math. And could somebody tell me what's your answer if somebody does that? Yuska says 46.89. I want everybody to maybe try it. Tell me what you get. You get something around the lines of like 46.89. Okay? But what's really awesome is that that step that took us, exactly, Elizabeth, that step that took you like 20 minutes by hand, you could do it with your calculator. All right? So what you would do, as I said at the very beginning, you could do 100 is equal to the present value. You could do 400 is equal as your future value. You could set your IY as 3, right? IY as 3. You could set your payment as 0. And then you could just compute for n, right? And obviously make sure to put your present value as like minus 100, right? Just put your present value as minus 100 and then compute for n. And then you get 46.89. I don't know if you can see this properly or if this is being mirrored, but Shane, just put your present value as minus 100, right? Because it's money leaving you. So 2 ways to do it, super easy. Shouldn't take you more than like 40 seconds on an exam. If you're really good with like math and that's like simpler for you and you're more comfortable that way, go about it doing it in that sense. If not, use a calculator. Maybe you'll get an error if you forget to put your present value as a negative amount, but it's a very easy step. Okay. So overall, are we good with A? Was that pretty simple, pretty straightforward? Yes, pretty easy. Any questions for A? No? Okay, no problem. I know that we're getting tired. Even myself, I'm getting a little bit like my energy is fading slowly, but we shall prevail and we shall continue. Okay? So this one's a really important trick for you to know. Okay? We're going to read the question and then I'm going to tell you a little bit more about it. Assume that all interest rates in the economy decline by 1%. So we're telling you that rates will fall by 1%. Which of the following bonds, okay, so we're looking at bonds, will have the largest change in price, okay? In other words, a really good way to think about this is which one is the most volatile, okay? Or risky, or literally which will change in price, okay? So we're trying to figure out what will change the price of a bond, okay? That's what we're trying to figure out. What will change the price of a bond? And if you guys remember our session that we did back in the days when we had essentially our session on equity and bond valuation, we looked at a little bit at the three big topics, big factors that affected the price of a bond. And we also talked about the bond yield curve and what happens to the price of a bond when a interest rate changes by just 1%. Okay, so all these factors are going to be pretty important for us when we do this. Now, look at that, that's solid. And the best way to go about this is really when we're looking at these, actually, no, I'll do one thing. I'll kind of list the factors real quick, just for you to know what they are. Then I'll tell you which one is the most important when doing these questions. So N is a factor, K is a factor, and then the coupon is a factor, okay? So those are the three main factors that we really care about. And the big factor that we're going to look at when we're doing questions like these on your exam, which are trying to figure out which one is the most volatile, the best trick for you is to look at YTM. Okay, always look at YTM. All right, always look at YTM. And the reason why you want to look at YTM is because we know that the smaller the K, the smaller the interest, the smaller yield to market, the yield to maturity on a bond, the more volatile it is to a fluctuation, okay? The more volatile its price. 1% change. Yeah, Elizabeth, exactly. That's pretty much it. But you can really only look at the yield to market. And only by looking at the yield to market, you'll figure out that, hey, the bond with the lowest yield to market already there will probably have essentially the most volatile change in price, right? Because we understand that that's the case with bonds. Okay, so already there you would know that the answer for sure would have to be 1. However, you want to be able to essentially rank these different bonds because sometimes they may have different years. In this case, they don't, but they could have different years. And they could also have different coupons, okay? They could have different coupons. And also different frequencies, okay? So we could all kind of highlight these in different colors. So they could have different frequencies as well, as you can see. And the idea here is that the biggest factor that's going to affect the price of a bond will be the YTM, okay? And the smaller the YTM, the more the price will change. And that's why we took number 1, because it has the lowest YTM. And then after that, you could also look at the coupon rate, okay? Because the lower the coupon rate, technically, the more volatile the bond will be. But really, after all this spiel, the last 4 minutes, what you really want to look at is the YTM. And the YTM will give you the answer. In this case, the YTM that's lowest is number 1. And for that reason, number 1 would be the answer here. I'm trying to think about maybe different things that I could share. I feel like that's really the best practice, the best approach to take when you have a question like this on the exam. Really look at the yield to maturity. The one that has the smallest one will probably be your answer. And yeah, that's pretty much it. So overall, are we okay with that rule that you want to look for YTM? The one that has the smallest one will obviously be the one that could be the most volatile in terms of change in interest rates, because we know that at smaller interest rates, there are larger changes in prices for bonds, okay? And once again, you can see this simply with our bond yield curve, in which you notice that the most change in price, so if this is price and this is yield, you notice that the highest change in price occurs right here, okay? When there's a small interest rate, all right? Overall, everybody else, are we okay? How are we feeling? Any questions? The rule here really, I'll literally read it verbatim, is to say, the smaller the K, the higher the impact of a change in interest rates. So you're always looking for the YTM, okay? That's the rule. And now the next one, pretty straightforward, pretty easy, is we're gonna look for which of the following investments provide the lowest EAR. So this question is pretty jokes because they're telling you, hey, we're not looking for the highest one, we're looking for the lowest one, okay? So that's pretty interesting. And I'm gonna ask you all, is it number 1, number 2, or number 3? What does everybody think? Is it number 1, number 2, or number 3? What do y'all think? One, 3, 2. Okay, so let's do this. When you have questions like these on your exam, you want to group them into buckets. Okay, you want to group those who have the same interest rates. Okay, those who have the same interest rates, you want to compare them together. In this case, we have option 1 and option 2, who have the same interest rate, but they have different compounding periods. All right, so let me ask you this. If 12% is compounded semi-annually, it means that it's compounded twice per year. And if it's compounded for number 2, compounded monthly, it means that it's compounding 12 times per year. So between 1 and 2, which one will have the highest effective annual rate? Which one? Let's ask everybody. 2, right? Because it has more compounding periods. So for sure, number 2 is wrong, right? Number 2 cannot be it because we're looking for the lowest EAR, right? So number 2 is bigger than number 1. So 2 is bigger than 1, therefore 1 is no good. So now we can compare 1 and 3 together, okay? So you want to see which one will have the actual lowest quarterly compounding, okay? I mean, not quarterly, the lowest effective annual rate. So now it's really a question of putting stuff in within your calculator. Because it's kind of hard to play it by ear here and try to figure out which one is actually the lowest, you can plug it into your calculator and see, well, okay, if 12%, or just use the formula, if 12% is compounded semi-annually, right, what would be our effective annual rate? And that's going to give you an amount. And then you would compare that amount to if this number here divided by 4 to the power of 4 minus 1, what would that give you? Then you compare the two and you find the smallest one, right? And in this case, the answer should almost 100% be always the smallest interest rate. But I would definitely compare the two. So you'd compare number 1 to number 3. Now, Elizabeth says that number 1 is 12.36%. Now, what about number 3? What is that compounded quarterly? So 11.4 divided by 4. Oh no, that's like what? 5.75. 5.75 divided that through 3.86, something like that. So 12.50. Really, that's crazy. Cool. So we have our answer. The lowest one would be 1. And I'm going to try it just for fun. You got 12.5 for number 3 for this one, or you're talking for essentially this one? Because for number 3, oh, I think you're doing like one by one. Gotcha, gotcha. I wouldn't do that on an exam. I would just like compare like objectively between the percentages. But for number 3, I'm pretty sure if you do 11.5%. Okay. Let me just see, because me, when I do 11.5 divided by 100 plus 1, I mean 11.5 divided by 100 divided by 4 plus 1 to the power of 4 minus 1, I get something slightly different. Oh, okay. Because I get 12.05. That's why I was like, it can't be number 1. It should probably be number 3. But it's okay. We're all getting a little bit tired, so it's totally fine. But in this case, our answer would be number 3. So I'm going to take a step back, just kind of like restructure ourselves a little bit for C. So when you have a question like this that talks about the highest effective annual rate or the lowest effective annual rate, what you want to do, the first thing, is you want to group essentially the options that have the same quoted rate together. In this case, number 1 and number 2 had the same quoted rate. Then, to make it super fast and easy for you, you're going to choose the one with the highest number of compounding periods or the one with the lowest compounding periods. Obviously, if we're looking for the lowest EAR, you're going to take the one with the lowest compounding periods, right? Because that one's going to have less compounding periods, such that its effective annual rate will be smaller than all the other ones. That's why in this case, number 1 was our selection, because semi-annual compounding is smaller than monthly compounding. And for that reason, 1 must be smaller than 2, just because they have the same interest rate, the same quoted rate, but with different compounding periods. So once again, you take the one with the smallest, lowest amount of compounding periods. Then, if you want to play by ear, you would compare that to the different interest rates available to you. So 1, 2, 3 in this case. However, I would definitely recommend just plugging it into your calculator. Although it's like obvious, you should still plug it into your calculator or into your formula, just to be able to see whether they're actually, smaller and or bigger than each other. And in this case, when you compare number 1 to number 3, as you can see at the bottom of the screen, we notice that number 1 has an effective annual rate of 12.36%, whereas number 3 has an effective annual rate of 0.5%. So for that reason, it's obvious that number 3 is smaller than number 1. And for that reason, number 3 is the investment that provides the lowest EAR. So overall, if you see this on an exam, do you know what to do? I know we were kind of walking through it, but overall, like, do you know what to do? Are you okay? Or is this good? Okay. Good. Amazing. So we got this. We got to continue. We got to move on. Okay. So overall, how are we feeling? Like, just consensus. Are we okay? Are we still here? Are we vibing? Are we good? Good. Amazing. So let's go. So now question 7 is a dividend question. It's a pretty funny one, but it's very easy in the things that you need to do. But you need to be able to just understand that, once again, the timeline will reign supreme. Okay? And you'll see what I mean in just a second. So let's read the question together once again. And we're going to identify a few things. So there's this company called King Ijnu, and its first quarterly dividend of $2 per share is expected to be paid in 6 months. So already now, we should have a few, bells that are hitting us, okay? We should be notified that, okay, something is a little bit strange here. Because 1, we're dealing with, exactly, we're dealing with something that's happening quarterly, okay? And we're also telling you that this is supposed to happen essentially 6 months from now, okay? So we're like getting a little bit lost. we're like, what the hell is going on? Usually we deal with something that's annual, right? We deal with something that's happening every year. But in this case, we're dealing with something that's happening every quarter. So it's getting strange really quick. But honestly, it boils down to the same thing, because all that we're doing is we're going to do the same process, but we're going to just use quarters instead. Okay, so instead of using years, we're just going to look at quarters. It boils down to being the same thing, but we're going to use quarters. Okay, let's continue to read the question. So paid 6 months from today. From then, dividends will grow by 2% per quarter for 3 years. Okay, remember what I said before. When you have a number of time that's provided, it probably means that we need to break down this question into categories. Okay, because it told you for 3 years it'll grow by 2%, you need to assume that that's a only small definite amount of time. So there's probably going to be another portion to this question, and there will be, because that's how it goes on exams. So we could actually highlight this in another colorway. All right, so for 12 quarters following the first payment. Now, after 3 years, put this in blue. After 3 years, the dividends, all right, so after 3 years, the dividends will start declining by 1% per quarter in perpetuity. So our dividends will actually become smaller every single quarter forever. So now assume that the company's required rate of return is 15%. So we could go back to yellow. The required rate of return is 15%. And that is effective semi-annually, or like it's the effective semi-annual rate. We're asking you, what is the price of a share of this company today? So it's definitely a strange one. You know, there's a lot of stuff, but what's interesting is that we could, once again, break it down, build a timeline, and kind of just highlight the main pieces and make it work for us. So the first step is we're going to try to make this timeline. We're going to try to identify the highlights, the things that we've highlighted, and put it through our timeline and make sense of it as we go. So as per usual, we typically always begin with t equals 0. All right? And because we're dealing with quarters, we're dealing with 3 months at a time. Okay? So that's pretty important. We're dealing with 3 months at a time. And in this question, they're telling you that the first dividend that will be paid every quarter is paid in 6 months. Okay? So if this is T1, this is T2, and this is T3, when is our dividend, our first dividend, occurring? When is our first dividend occurring? Where should I put it on my timeline? T0, T1, T2, T3, where? If this is us today, and we know that this is 3 months, and this is 3 months. So 3 months, 3 months, such that we would be at 6 months here from today. So where is our first payment happening on our timeline? Where would we put it? We would put it at T2. Exactly. Amazing. So we would put our first payment at T2. And we know that that first payment will be right here. We know that our first payment will be right here for $2. And we know that that's going to grow for 3 years. Okay? So we know that that's going to grow for 3 years. Obviously, I'm not a lunatic. We don't even have space for that on our timeline. So we're going to skip a few years. We're going to bring ourselves, right? If we know this is T2, we know this is going to happen for another 12 quarters. So essentially, you would have something like this. Yep. So you'd have 1 quarter that's happening, and then you're going to do this for 12 quarters all the way to T14. Put T15 here. So we know that this is going to grow by a specific amount all the way then. All right, and we know it's going to grow by 2% every single quarter. So we could draw it up somewhat nicer. Such that this would be the last step of our first part, where it's growing by 2% per quarter. This would be our first part. Okay. So our first part would end right here at T14. And then we know that right after that, starting T15 all the way to infinity, we know that our dividends will decline by 1% every single year. So we could put that in blue. I believe this is color. So we could put this in blue here all the way onwards. Just like that. And we know that every single period from now on, it'll decline by 1% every single quarter. Okay? So we could call this as being essentially part 2. I'll put it right here. Or just part B. Okay? So before we proceed, are we okay with the timeline? Do we understand that we have part A and that we have part B? That part A is occurring from T2 technically all the way to T14, and that part B is happening from T15 all the way onwards. Are we okay with that? Yeah, for sure. So once again, what I want to make super clear, super duper clear, is that on exam questions, what they may do is they're going to use years to like kind of break down the question into segments, right? What we had highlighted in green, it said that for 3 years, you're going to have something happening. So we know that that's one part. And then for what we highlighted in blue, we said after those 3 years, right after that, forever, we're going to have something else that's happening. So what we do is we take our timeline and we make sense of it. All right. And in this question, listen, it's like if we were dealing with years, just we're dealing with quarters. So it's a little bit of a, of a mind boggling question, if you will, if we want to use, polite terms. But other than that, it's not very complicated. Okay. So the thing is, though, we have a little bit of a problem. In this question, we were given an effective semi-annual rate. Okay. We were not given an actual I think we left, but an actual effective quarterly rate, and that's what we're going to want to use. So that's going to be the first step that we're going to need to do, because for us to use either a growing perpetuity, a growing annuity formula, or a constant growth DVM formula, we're going to need to actually allocate the right K. So the first step for us here is to solve for our effective annual rate. So let's start with that. So part 1, solve for effective quarterly rate. So we're going to solve for our effective quarterly rate. Now we know right now that they gave us an effective semi-annual rate of something along the lines of 15%, if I'm not mistaken. Now we want to get our effective quarterly rate. Okay, so essentially we're taking back one compounding period. Now this is not as easy as simply dividing this by 2. Unfortunately, we need to use our formula. The formula we could use is as simple as this. We could say that our effective quarterly rate, in this case, not so much, but we could try to plug it in. So we know that we have our effective quarterly rate right here, okay? And we know that this is happening every single quarter, all right? There may be a typo. I'm just trying to see if anything is okay. 15%. No, it would make sense. Yeah. Okay. So how did you guys go about this? If you want to put it in the chat. And there's 2 ways about going about this, actually. I'm gonna get you guys involved. How did you go? Why did you get 3.68%? Okay. And that's a fair way to go about it. Now I'm curious to see, what if you try to multiply that number by 2? What do you get? Just for fun. If you were to multiply that number by 2, what do you get if you do that? the number that Elizabeth and Yusha got. If you multiply that number by 2, what do you get? Just for fun. I'm curious to see. Yeah, 7.36. Okay. Well, what I'll show you here is kind of an interesting trick. But remember when we had our effective annual rate? Remember when we had that amount? Okay, we had our effective annual rate, and we were looking for an effective periodic rate, right? We were looking for an amount for a X amount of time, right? It could have been for 5 years, could have been for 2 years, could have been for a lot of different things. Okay. And what we did is we used the following formula. What we did was this. We did our effective periodic rate is equal to 1 plus our effective annual rate to essentially the power of 1 over m minus 1, right? We were moving from one effective rate to another, okay? We're moving from one effective rate to another. And simply what we did is we just did 1 over m, okay? So that's pretty interesting. Now what we can do though, is if we want to solve, and we could kind of use the same like optic, is if we want to solve for a effective semi-annual rate to an effective quarterly rate, we could actually use a very similar approach where we're moving, once again, highlight this in red, from one effective rate to another. If we're moving from one effective rate to another, we could use a very similar approach because it's essentially what we're doing. Okay. Now I'm gonna add one more topic. If we have an effective semi-annual rate, okay, how many times are we compounding per year? Somebody tell me. We're compounding twice per year. If we have an effective quarterly rate, how many times are we compounding per year? We're compounding 4 times per year. Okay, that's very interesting, very strange. Now, how many more times are we compounding from an effective semi-annual rate to an effective quarterly rate? How many more times? 2 more times. 2 more times. Okay. So there are a few ways about going about this, but I'm going to show you all a trick. It's a pretty cool trick that you could add to your formula sheet. If you're moving from one effective rate to another, and I'll give you a proof right after, okay? Especially if you're moving from an effective rate that's not an effective annual rate at the very beginning, okay? That's, I guess, like the caveat. If you're moving from an effective rate that's not an effective annual rate, all right, to another effective rate, a really good trick to take is to look at how many compounding periods are you adding or losing from another, okay? In this case, you're adding 2 compounding periods. Technically, it's like if your M from an effective semi-annual rate to an effective quarterly rate is equal to 2. That's essentially what's going on, right? Because that's like the effective compounding periods difference between the two, right? You're changing from an effective semi-annual rate to an effective quarterly rate, and we know that you're going to be compounding 2 more times per year in that setting. So what you could do is you could actually write it as something kind of cool. You could say that your effective periodic rate is equal to 1 plus the effective semi-annual rate that you have over 1, to the exponent of 1 over m like star, being the number of periods difference between the two, such that in this case we could say that the effective quarterly rate would be equal to 1 plus 15% to the power of 1 minus 2 minus 1. It would give you something like this. Now, could somebody just plug it in just for fun? And then I'm going to give you a little bit of a proof for why this could work. And there's a few ways about going about it. You could use your calculator. You could also go the long route. But this is a quick way to have a really good trick when they throw you this one in a lifetime curveball on an exam. So plug that stuff in and tell me what you get as your effective quarterly rate. After that, it's very simple. Yeah, exactly. Exactly. Yes, same. Perfect. Okay, so you get an effective quarterly rate of about 7.238%. So you're probably like, listen, man, I looked at your notes, I looked at your recordings. I've never seen this formula in my life. Like, I don't understand what you're doing. I'm gonna give you a proof, all right, for it to make sense to you. So I can totally see why you're like, what's going on here? So a really good way to check this out, okay, is let's go back to our initial example. And this one, like you've done it like 1,000 times at this point. So you're used to it. Remember when we had like a perpetuity questions where we would group essentially our payments? So we would say, well, it wouldn't make sense to use an interest rate of 1 year for 5 years. So we have to find our effective periodic rate. And it would look something like this, right? We would have, I don't know, EAR is equal to 12%. And we would say it's for, 5 years that we're looking for. So we would say our effective periodic rate would span, 5 years. So we would say, all right, well, your effective periodic rate would be equal to 1 plus 12% to the power of 1 over 1 minus over 1 over 5 minus 1. So far, do you guys remember what I just put in blue? Like, is that something that we recall that we've seen in the past? Like, that's something that we're familiar with, right? Like this little dance that we did here. Yeah, it's something that we're familiar with. We've seen it thousands of times, not thousands, but quite a few times. So a few things to note. Number one, I guess I'll write number one, is we're moving from an effective rate, right, to another effective rate. That's the first thing to understand, okay? But the thing is, how many more additional periods or less are we getting here? If we were compounding once per year, and now we're compounding once per 5 years, are we making more compounding periods or less compounding periods? We are moving from once per year to once per 5 years. Are we getting more compounding periods or less compounding periods per year? Yeah, we're getting less, right? We can highlight this one. We're getting less. We're getting less compounding periods. So the difference between the two would be once, quite literally every 5 years. So you're essentially once every 5 years, right? So in this case, your M would be 1 over 5, right? Assuming that this means 1 per 5 years, and assuming that 1 over 1 would mean 1 per year, okay? So that would mean that 1 per, like essentially, you're gonna have to wait a fifth of 1 year to be able to compound your interest, right? That's what we were doing. But in our example that we had right here, where we're moving from one effective period to another, it's actually different. In this case, we're actually compounding more, right? We're compounding twice. We're compounding 2 times more, right? And that's why, if you look at the numbers, instead of having our M being equal to 4, we had our M being equal to 2. The reason why is because, well, in this case, you're compounding twice as much within that period of time, right? So for that reason, if we compare the two, we're only compounding twice as much, not 4 times, right? We don't care about that. We're not going into that example. We're not moving. Our M would only be 4 if we were moving from an effective annual rate to an effective quarterly rate. But because right here, this would mean that M is equal to 4. But because we're moving from an effective semi-annual rate to an effective quarterly rate, the difference in compounding is only 2 periods. And that's why M is equal to 2. So do you see like what's happening in terms of movement? And I'll give you another example just to make sure that we're on the same page. If we were moving from an effective annual rate to an effective, I don't know, what's a semi-annual, to an effective monthly rate, okay? What would be our M? Our M would be, what would be our M? Monthly. It's happening every month. It'd be 12. Exactly. Our M would be 12 because we're compounding 12 times per year. Okay. So you always want to look at the difference between the two. What's actually happening? Okay. I don't think that they're going to be as crazy as to give you something like that, but that's a really good way to play around with this. Another, I'm kind of doing like a impromptu workshop on rates. And another way to go about this, which you could do, by the way, is you could decide, you know what you could have done if you're really uncomfortable from going from an effective semi-annual rate to an effective quarterly rate. What you could do is you could actually do a proxy move. You could go from an effective semi-annual rate to an effective annual rate, and then move yourself to an effective quarterly rate. Because like that is a little bit more digestible and you would feel like you know what you're doing, but that's another way of going about it, okay? So both options, they work really well. Anyways, overall, if we kind of like finish my spiel, do we understand why this is the amount that we got? Are we okay with that now? Like, is that fair if we're moving from one effective rate to another? All right, do we have any questions? Like, how are we how are we feeling about this? Okay, you got it. Nice. Well, what about the others? How do we feel? There's two more people, Yusha and Elizabeth. Good. So like this made sense? Like, did this make sense? That's what I'm trying to figure out. Okay. Anywho. So we got our rate. That's what matters. Okay, it makes sense. Cool. So now we have our rate. Now, once again, if we, and that's the only ambiguity that we have here. Okay. So now that we have that, okay, now that we have that, we could make the second step. All right, we could make the second step. Okay, so now we have, once again, we have part A. That's what we want to do now. Now, would it make sense to use a perpetuity formula here? Would that make sense? Should we use a perpetuity formula for something that lasts from T2 all the way to T14? Would that make sense? No, it wouldn't, right? What formula would we use here? We would use a growing annuity. It's almost like they do the same thing on these exams. It's kind of crazy. So we know to use that. So we could go and kind of do our part 3. I mean, part 3, I'm lost. Part 2, which is solve for A. Just solve for A, all right? So we would have part 2, which is solve for A, and we would have to use our perpetuity, our growing annuity formula, which says the following. K minus G, 1 minus 1 G, 1 K. So we would have our formula, okay? Now what we want to figure out is we want to figure out, well, how do we kind of want to play with this, okay? How do we want to play with this? Now, in this case, it's kind of like what I said before. If we look at our timeline, we know that, listen, we could make this payment 1. We could make number 2, $2 our payment 1 because it's going to bring us right here. It's going to bring us at T1, right? That's going to be our PV. It's going to bring us a PV1, and then we could just discount by 1 period. So that's not a problem. We're like kind of okay with that, right? That's not too bad. We could kind of like stomach that. So that said, what I'd like you to do is I'd like you to kind of work with me, and we're going to identify the pieces. So we know that payment 1 is equal to $2. We're going to look for K, G, and N. So what is K in this case? What is K in this case? If we know we're working on a quarter-to-quarter basis and we found our whole number exactly, our K would be 0.0723. In other words, 7.2381%. And in this case, our G, right, it's growing every single year and it's growing by 2%. So we know it's 2. All right. And this is where it gets kind of funny. I'm curious to see what is our N? How many payments do we have here? How many total payments do we have here? Is it 11, 12, 13, or 14? What is our N? We have 4 options. 11, 12, 13, 14. What is our N? How many total payments do we have? Now let's think about it. Let's think about it. If our first, and we can even use our hands. We know for sure that $2, right, is going to grow for 12 quarters. Okay? 12 quarters following the first payment. The first payment is $2. And then it's going to grow for 12 quarters. It's going to grow 12 times. So it's going to grow 12 times, right, up until the last payment that has grown for, the 12th time. And then we also have our first payment of $2. So how many total payments do we have? If we grew for 12 quarters, then we had our first payment. Right? You have your number one payment, number one, that's your first payment, but then it has to grow 12 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you get all the way to 13. You have 13 total payments, but that payment grew for essentially 12 periods, such that you have 13 being your total N. Does that make sense? Do we understand how you had your first payment, then you had that payment grow for 12 additional quarters, right? Such that it would be your first payment. There you go. This is just, it's an annoying nuance. It sucks. I'm not even gonna lie. It's a bad nuance. It's not the cutest nuance out there. Yeah, no, 100%, right? It's 100% terrible. But that's why it's really important to use your timeline and kind of figure it out. Because I'm pretty sure if we use our hands, once again, if we do T2, so this is T2, T2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You go all the way to 14, you still get to if you go all the way to T equals 14, you still get to 13 total payments. So I'm not gonna lie, I got like a 96. It was between like a 93 and a 96 on the final, I forget. On the final, I was literally like this, counting like a kid. I didn't care. I was like, I have no shame. I'm gonna get the best grade out here. So use your hands. It's totally fine. One by one. 1, 2, 3. Do it twice just to be sure. You really want to make sure that you have the right answer. Okay? The best students do it, and the worst students should do it. So I think that you should do it. So with all those different numbers plugged in, so we have everything. We know that this is going to be 13, and this is 2%. This is this number. This is this number. Can somebody tell me what's our present value for this? Somebody tell me what's our present value? Height. Present value. Period 1 is equal to 18.27. We all know that that's not our present value at 0. So you have to take that amount. And because we were at PV1, we got discounted for 1 period. So in this case, you're going to discount it by this amount. Such that, can somebody tell me what our present value 0 is actually? Merci beaucoup. Arigato, arigato. That is exactly it. So we have 1704. Cool. So we have that. Now we did this portion. Now we got to move on to the next portion, right? Which is our actual perpetuity. Because we know that after 3 years, this dividend will start declining by 1% every quarter. Okay, so now it gets kind of easy. It's easier, if anything. So we could go to part. which is our perpetuity. In other words, our DDM portion. So in this case, we know that a formula, once again, is this classic. It doesn't change. What we do is simple. What we do is very, very, very simple. We just do this is equal to D0, 1 plus G over K minus G. It's as simple as that. We don't need to change anything. However, we want to be able to identify, well, what's going to be our numerator? What's our K and what's our G? We already know what our K is. It's written right here. We already know what our G is, but I'm gonna ask y'all still one more time. What is our G in this case? If we know it's declining by 1% every year. What is our G? Exactly. Thank you, everybody. Amazing stuff. Our G is gonna be minus 0.01. So what's awesome is that because it's minus 0.01, K minus G actually becomes, in this case, low-key K plus G, because this one's a minus. So essentially, you're going to have 7.2381% plus 1%, because the minus won't work, right? A minus gives you a positive, okay? So that's what your numerator is going to be. So that's pretty awesome. And then what about your denominator? What about your numerator? What about what's going to be at the top? We know that what's going to be at the top is going to be something interesting, right? It occurs right here, right? It occurs right here, okay? And the thing is, we need to assess, right? So check this out, Elizabeth. We know that this is going to be growing for 12 periods, all the way to T14. So we know that this amount right here, and I'll ask everybody to tell me if that's okay, it's going to be the following. It's going to be 1 plus G to the power of 12. Are we okay with this? Is that fair? This amount that I just wrote? Oh, sorry, that's kind of ugly, but this is essentially our value at T equals 14. The thing is, because we want to use the perpetuity formula, we need to start at T equals 15. Okay, we need to start at that point. So in order for us to start at that point, we're going to have D0 times 1 plus G, well, I guess the first one, to the power of 12 times 0.99, right? Because it's going to be 1 plus G2. And G2 is equal to essentially 1 plus minus 0.01. So this is what our formula would look like for our perpetuity formula. So this is what our numerator will look like. Is that fair? That we have our initial dividend that's growing for 12 years, right? That's our 12 here. And then it's essentially getting smaller by 1% every single year, such that it's equal to 0.99. Are we okay with that? Is our numerator okay? Are we fair? Is this good? Are we? Yeah, but the timeline really does help. And also we're 3 hours, we're like almost 4 hours in. I'm the tutor here and my brain's fried. So I'm sure that yours, you're like, this is a lot of stuff at this point. And these are not easy questions. This is not like a mock exam where you're just doing like the easy stuff and they're just trying to take your money. Like we're really doing the hardest questions out there. So it's totally normal that like you're up there right now. And we're probably gonna end it after this question, and I'm gonna do a recording, or we're gonna book we're gonna just do another session tomorrow for free, where we could like cover the last 6 questions. Just because right now I don't feel like it's moving as fast, which is normal. It's like if you go to the gym or if you practice for a specific sport, or even if you study, right? At a certain point, your brain doesn't want to deal with it anymore. So we'll finish with that last little kick. All right, last little kick. And think about it. This is going to be our numerator, right? Because we grew for 12 periods, and then we need to essentially decrease or decline for 1 period, such that if we plug this into our formula, do it like that. If we plug this in within our formula, we're going to get our present value at period 14 that's going to be, as I said, D0 times 1 plus G, the power of 12 times 0.99 over 7.2381% plus 1%. Can somebody tell me what's our present value at year 14? If you plug all that good stuff in. Very well done. Exactly. So that's our value. Maybe we're missing a few decimal points there, but that's our value. And of course, we know this by now. It's I'm like preaching to the gospel, but we need to get our PV0. So you do PV14 over 1 plus K, the power of 14. And then can somebody tell me what's our PV0? Amazing. Yeah, that's fair. 1.46. So that's our PV0. Okay. Now let me ask you the final question for tonight's session. Is that our final answer? You got to add them up together. Exactly. Thank you. Well done. So now all you got to do is you're going to do PV0 for A, I guess, plus PV0 for B. That's going to give you the present value of the equity. So what is that equal to? 28.50. And that's your answer. Now, listen, do I think this is a hard question? Yeah, it's definitely like on the exam, this would be like a curveball for sure. Do I think it feels more overwhelming than it is because we're at the 4th hour? 100%. And I feel like if this was the first question we did in today's session, it would be a breeze because all of you guys did all of the other questions so well. So I would not take this as like, oh my God, it's just you're tired. It's a Thursday night and it's 9 p.m. You want to go do other stuff. Totally get it. But the only real nuance in this question, there were two. One is the idea that we're not dealing with years, but we're quarters. It's a very rare chance that you'll see this on your exam, but it happens. So we were dealing with quarters. So we had to take that into consideration. And then we had to move from an effective semi-annual rate all the way to an effective quarterly rate. So that was kind of strange. But after that, it was easy, right? If you use your timeline on your exam, I don't think the numerator of a perpetuity would have been a problem for you, okay? So really, all in all, maybe we'll talk about it a little bit tomorrow. I feel like it was okay. And tomorrow we'll take some time to do 6 questions together because we're missing the 1, 8, 9, 10, 11. So yeah, we're missing like 6 to 8 questions to do. We'll try to like take an hour and a half. I'll try to have the solutions already ready beforehand so we can kind of walk through them. And like that, you'll have an additional set of exposure to questions. So on that note, I think we're going to call it a night, unless you have any questions. And we're going to set a time. Oh yeah, no, 100%. I went to the gym before because I was like, I'm not going to go after this. There's no way. So we'll meet tomorrow. God bless y'all. You got to put in the work. God bless y'all. And we'll talk about it on the chat. I'll put the recording immediately right now. It takes like an hour or two to like upload, like to download, and then I have to upload it. And then we'll kick the rest out tomorrow. So on that note, we'll talk to each other next time. Good night. Thank you. See you.